we make these social things interoperable, we can create the same dynamic as we did on the left, which is that a lot of stuff becomes possible that wasn't possible before. And that's a conjecture at this point. So far, what we have, the projects that are in here are the ones that are actually connecting as we speak. While many other things like whatever Instagram and what have you are not connecting far. But if you go to the, I have to stand here. I don't like to stand at a lectern, but anyway, here we are. I have to stand here so that people remotely can. But basically, just like back in the internet days, it wasn't obvious whether anybody should connect or should not connect to this. And AOL defend its turf by the internet, but at some point they gave in. And the idea here is that maybe the same thing, and it will enable a lot of new businesses and a lot of new functionality, just like the internet level thing did that back in the 90s. That's the conjecture. Let's just, and when I'm talking about the social web and the Fediverse, I'm using those largely interchangeable, but the idea is there's a bunch of websites, like some of them on here, where you can do social stuff on them. Like, for example, you can post something on WordPress, for example, and people in other places, on other social networks, can treat it as if it were local, right? Which is sort of the same thing. You didn't really care whether one university or one company, OL, hosted something once we got the commercial internet. Possible. So that's the big context, and let's go into the technical part. So there's a bunch of, actually I should say on this, there is still a bunch of uncertainty exactly what the protocols are and how this is all going to come together. And it's an area of active innovation. Connecting the social web is a much more difficult technical problem than connecting on a networking level, a much higher level functionality. So it's harder to do. There is more, if you wish, between things. Personally, I think, and where it comes down to, we don't know. The largest network at this point that is actually decentralized is built around a standard called ActivityPub, which is what all of these guys use, threads. So let me talk about this a little bit. What is this? And there are bridges to other things as well, so it's not a closed system. It's an open standard, but you can implement it. So currently there is almost 30,000 servers online, live, interacting in these protocols today, which is an amazing number. As decentralized systems go, these are independently operated servers. Almost none of them are operated by the same organization. There are somewhere in the order of 10 million users, of which there are about 1 million active, plus minus. As a decentralized system, it's hard to tell because nobody really has good numbers. There's at least 94 independent applications of implementations of the protocols. I know that because when we look for Fediverse, what we should be testing, what's in scope, we found, without looking too hard, we found 94 implementations. I'm sure there are more. It's implemented in every conceivable programming language and stack. It's a lot of people like you who basically want to scratch the itch and say, I have this really cool programming language that nobody's ever heard of, and I'm going to implement this in my favorite language. Some of them are open source, some are closed. It goes from single instances, single person instances to Meta Threads project, which now has I think 275 million users. It's opt-in, but every Threads user has the ability. They're not entirely done with the implementation, but the signs are that they will be done by the end of the year. It works. So for example, one of my demo cases, when I don't want to do a demo of the Fediverse. I want to do that. One of my, I think, compelling demos that I have been doing was President Joe Biden has an account on Threads. Seems normal, right? Big social network presence account there. Now, I may not want to use Threads for all sorts of reasons. I might want to use Mastodon. Say, I can follow Biden on Mastodon. So I don't have to get, I don't have to see the algorithms, and I don't have to all the ranking and all the UI and so forth and so forth. So that's the kind of things we can do here. And I can interact and reply and all of it. One interesting thing about this, the ActivityPub Fediverse, is that it supports public, semi-public, and private messages architecture, which is something that other protocols don't do. We have this graduated privacy here, and the protocols involved, and I want to talk about those more, is a stack of protocols. It's not just one protocol. People usually talk about ActivityPub because that's sort of the core of it, but there's more than that. Based on HTTP on the bottom, so to speak. It's a symmetrical protocol, which is sort of unusual in that HTTP gets spoken in both ways. So if you have two nodes on a network, they can be clients and servers within milliseconds of each other, which is sort of a little unusual, and it creates some interesting problems. And then we build up on top. They're using HTTP signatures to authenticate requests. I can say it was me sent that. And then there is ActivityPub, which is basically a protocol that says under which circumstances you will send what to whom. And then there's activity streams, which is basically the content. What am I actually doing? And there's lots of extensions. For this to work, if you go back to, there's a really big proposition. QA is a real problem. Imagine you are somebody who has an implementation of the stack. You're very happy. You read the specs as you could. How in the world does this ever going to work in the real world? Right? For those of us who write software, as a profession, you go to your boss and say, yeah, the boss wants to know, will it work? Will the customers be happy? And you say, I have not the slightest idea.
Under event.
Right? Because somewhere over there,
Event.
somewhere over here, somebody might do something that you have no practical way of testing. And before I go into what we do with Fedi Test level, and this is my summary of how the ActivityPub Fediverse works on a technical level. And the base assumption, unlike other things like Blue Sky and Noster and all of the Farcast and all of these, the ActivityPub Fediverse starts with websites. There are websites. You want to connect them. Other things do other things, but that's the way ActivityPub works. So we have an A.example here on the left and a B.example. And on those websites, you have users. It's very much the system that we have grown up with. And what happens? Let's take this example scenario here. You have Alice here on the left, follows Bob, a follow, so that she receives the post when he posts something, right? But now it's across servers. So how does this work? And the way ActivityPub fundamentally works is that the protocol is a verb on a noun. And in fact, it's an extensible set of verbs and an extensible set of nouns. So it's a pretty extensible system. So for example, Alice here might say create, that's the verb. Note is the noun, which is she makes a post. These two things, create and note, published to others. Or for example, she might say follow, where follow is the verb. Yeah, Bob here is the noun. And like, and all of these kinds of things that you know from social media. So that's fundamentally what somebody might do on a site, so with a timeline going downwards. And then the same thing happens on the other side. It's a symmetrical protocol, so we have verbs and nouns there too. And so, for example, Bob here might say, I'm going to do the verb accept, and what I accept is the follow request from Alice. And by basically publishing this out, the whole thing can work. So let me go one level down into the protocol. So this is the high level of how this communicates. Now let me go one level down, see how it actually works like on the wire. And that's still simplified, but it is closer to the wire. So the first thing that happens, if Alice wants to follow Bob, is wants to have the use case, she receives the post from Bob. The first thing she wants to do is follow. How does Alice follow Bob? Well, she needs to have Bob's identifier, which in this case is Bob at b.example. she types that into her software. Let's say it's Mastodon or Threads or something. And the first thing that happens is there's a WebFinger lookup. WebFinger is this little IETF protocol that that's been around for at least a decade, maybe more. And it basically says, if I have an identifier, give me some metadata about it. And so the ActivityPub Fediverse basically uses this to figure out what's called the actor URI, which is now an HTTPS URI that represents Bob, where we can find out more about Bob. Now what happens is that Alice's software goes out with this actor URL and says, tell me something about Bob. What comes back is what's called an actor file, which has things in it such as their profile, where do I find the profile information? How do I communicate with Bob, basically? What's the endpoint to send him some box so I can see what happened? And now, what Alice would probably do is before that Bob actually, the right Bob, she probably, or Alice's software, will fetch his outbox, is essentially their RSS feed, so to speak. It's not RSS, but it's very similar. So it says, what has this guy posted in the past, the past whatever time window? So, okay, these look like the right posts. So that is another ActivityPub request, which comes back in activity streams content that can be parsed, and that's the thing that looks like your social media feed. And then she goes like, oh yeah, this is the right guy, the right Bob. I want to follow this. And so she sends this, or Alice's software sends a follow request. And as you will undoubtedly see very quickly, is that if sends this request without authentication, then anybody could make anybody follow anybody, right? I could impersonate somebody, claim I'm Alice, and make a follow Bob, and you don't even want to do that, which is why Alice will put an HTTP signature, which practically means you have an HTTP request, and it has some extra payload, and the extra payload is a digital signature on the request. So Bob can go and say, oh, this has actually come from Alice. Should I actually accept, should I ignore that request, or is this a valid request? And then, you can see the arrows here are, what I mean with the arrows is the client-server relationship in an HTTP request. So the WebFinger, actually, my diagram isn't actually exactly right. But basically, these are all HTTP requests. So the follow is an HTTP post that's signed. And then there's no return value really, except for a code. And then Bob comes back and says, okay, I'm going to accept this. He might also say reject if he doesn't want her to follow, which is another signed HTTP request. And then finally, Bob might post something new. And when they post something new, they create a create note, that's the verb and the noun. And now, given that Bob's software knows that Alice is following Bob, it can go through the list of followers and say, oh, better HTTP post that new activity, the create note, over to Alice. And then, for example, Alice might say, oh, this is a great note. Post with the activity like this note. And Bob knows that it's liked. So I'm seeing some nods and some not so nods. I don't know whether what I'm saying here makes sense to you guys or it doesn't. I see some thumbs up. Okay. Okay, some very high thumbs up. Okay, excellent. Okay, so let's go on the testing part. How would you test this? This is a complicated protocol, right? There's all these things happening. Oh, no. And one of the things that's really complicated with this protocol is to test something, you need to be in we have a distributed system here. And we need to get the system into the state so that we can actually run that code that says test what happens now. So if I wanted to see that Alice gets the post from Bob, and Bob posts, here are the things that need to happen before we even can get to the thing, right? So what we really want to test down here, where it says now this action, Bob creates the note, and it leads to this desired result to be verified post. But before to get there, we need to get the WebFinger file, get the actor file, some posts for follow and accept and all of these kinds of things. And so this is a non-trivial thing set up. And it's a distributed state, right, where you can't just basically take one node and say, and as we said earlier, we have implementations of those nodes in programming environment under the sun. And all of them are server-side applications as well. So it's not like you can run a little library or some such thing. If you take Mastodon as the most widely deployed open source system for this, Mastodon runs. It's a web application in Rails, but it also runs several daemons. Why? So for message queuing, outgoing. So you have to actually have these daemons up and before you can test anything. So this is not a simple problem. And so I have an extra slide on this one. So, which is the set of nodes in a test. So if I wanted to say I want to test this against that, it's a 2-node constellation, but constellations may be more complicated. So one of the problems is, as I just said, these things have databases and they have web server configurations and have you. Just installing such a thing is usually kind of an afternoon kind of exercise, right? If you don't know the software, it might take you longer. It's hard to install, some is easy. And of course, we don't actually know many of these stacks because there are so many of them. Nobody can know them. Next problem is isolation. You could say, oh, I'm just going to set up a test server and always test against that. The problem is, as we know from testing, not so great because you don't get isolation. Meaning that somebody else might run something against the same server and all of a sudden the whole thing. So that's not really what you want. Problem, return to a clean state, right? What you really want to do in testing is when we run the same test, always run it from the same state. Otherwise, we have no idea of it. Constellations with many nodes. Here is an example. It's actually a real, let's say, Alice posts something, Bob boosts the post, I think retweet, share kind of thing. And there's a third guy, Charlie, who replies to Bob on yet another server, and you can sort of see this can go with many, many servers. Now Alice goes ahead and deletes her post. It is sort of important that that post gets deleted everywhere. But Alice's server doesn't actually even know where that post went, because it was handed over from server to server. It would be really interesting to know, important to know, from a trust and safety perspective, that post has disappeared everywhere. How do you test this? Not simple. So we have, in many cases, constellations that have more than, I don't know, do you have your hand up?
No.
Oh, okay. Feel free, we're not a ton of people. So if you have questions, feel free to raise your hand. So you're setting a constellation up with many nodes is expensive to do even once. And we would like to do this, on a repeated basis. Another little problem. Let's say you wanted to run these things on nodes that are not on the public internet, and that will be a good thing because otherwise you don't get isolation. If you run it locally somewhere, turns out a lot of these applications work under anything other than HTTPS. They have safeguards built in, and the specs certainly require HTTPS, so you all of a sudden need valid. And then, as we found out the hard way, these applications actually implement various defenses, meaning you cannot, without special setup, you cannot actually run it on a local IP address because it will refuse to talk to somebody else on a local IP address. Yes?
I may be getting ahead of you, but it seems to me that one of the other problems that you have to test is how does the system work in a failure mode?
Yes.
Because my observation doing troubleshooting, and I talked about this yesterday, was a lot of times the error messages are confusing.
Yes. Yes.
And so I'm wondering if you're going to cover that, or is that an even bigger can of worms you don't want to address?
I want to be most of the time on the smaller can of worms. But I'm with you. And in a decentralized system, we have the extra difficulty is that for good practice, a lot of the error messages that are publicly reported are not very telling, right? And that's intentionally because otherwise you give your attacker a mechanism of figuring out more about what your application looks like. And so So it's even harder. So let's go over to the Fedi test part. We're about halfway. So Fedi test is several things. It's a test framework, like there are so many other test frameworks, unit test frameworks and what have you. It's a test framework like that, but it is made specifically for interoperability tests of systems that are distributed and heterogeneous. And by heterogeneous, I mean where the nodes are not running the same code. If you have the nodes all running the same code, you have a distributed system maybe, but it's a somewhat simpler problem than if you're running different code at different places. So that's what it is for, using complex protocols such as the ones where the role of client and server moves back and forth many times. We didn't actually meant to write an entirely new test framework. We just wanted to test, but we looked around and basically it seemed impossible to coerce any of the existing code we could find into something that could really not confuse more than. The second thing we do is we're building a test suite for the ActivityPub Fediverse. Practically means a bunch of tests that can actually test this in a way that is independent of the applications being tested. Okay, because if you want to know that Alice gets the posts from Bob, that has nothing to do with whether Alice uses Mastodon or PixelFed or the same tests. So we want to define the tests in a way that's independent of the application. And then we have this abstraction called a node driver that basically says, oh, and this is how we talk to an actual implementation. There's a footnote here. It can also be used for non-Fediverse protocols. It's with Fedi test, we of course won't have the tests for it, but it is intended to be a that's generally applicable. Here's my architecture slide. There's a lot of boxes. Walk you through it. So I would point over here, but then nobody can hear me on the remotes. Do this kind of thing. On the bottom right, we have this white box called constellation. Are the nodes that we want to test. Let's say there's 3 nodes. Node, think of it a Mastodon instance or a Lemmy instance or Flipboard or Threads or something like that. And these nodes are talking to each other in some way, and we want to figure out whether that works. Some of those nodes can be implementations like the ones that I mentioned. Others might be special nodes specifically for testing. We don't have such a thing. Well, we only have rudiments of that right now. And to your point about failure scenarios, one of the things we want to test further down the road is not only misbehaving nodes and what happens, but actually active attacks. What if some of those nodes were actually hostile? What happens then? And so it could be all sorts of nodes like this. Then at the very top, we have this green box called the Fedi test framework, which runs all of this. And within that, and then on the left, we have this notion of a test plan. If you're familiar with test frameworks, all the test frameworks have a test plan, except that they usually hide it. Test plan is the thing that it executes when it's decided what tests to run, right? If you're running like PyUnit or you're running JUnit or whatever you're running, when you invoke this thing, the first thing it does is figuring out what's the test I'm supposed to run. And then it says, I'm going to run this first and that afterwards. And that's usually hidden from you as a developer. And so in our case, we make it explicit. And the reason why I make it explicit is because it's so expensive to set up these nodes. So if the framework is a bit too smart about what it discovers, it can make the whole thing take just so much longer that we basically wanted to have the ability for the developer to define in a very, very detailed way of what actually happens. And so there's this test plan, and the test plan has a bunch of tests that are going to run in a sequence. And the test plan basically starts with set up the nodes we need, run a bunch of tests, and tear them back out. And what happens here, in the way that happens, boxes in here, the node drivers and the node proxies, call them here. The node drivers are software abstractions. Think of it like abstract base classes in your favorite programming language, which provide some abstract methods for what needs to happen, such as create node. And then there is specific implementations that know how to do this for a particular application. So for example, there is an implementation of create a Mastodon node by installing it locally. or create a WordPress node by installing it locally. Some of them are cop-out nodes. One of them is, dear user, now do whatever you need to do so there is a node of this type. And once you're done, please tell us where it is. So that's the fallback part, because that allows us to test with more manual work without doing a bunch of programming for this particular implementation. So we try to get the cost for the developer of a new application to get as low as possible. We can't go very, very low, but we can go as far as we can by going from, this is entirely manual, and then you gradually automate more steps. So the node driver basically just knows how to do, give me a new node, and then tear it back down. And then we have these node proxies. And the node proxies is the way the test interacts with a particular node. And it basically does two things. It makes the node do stuff, and it observes what the node knows. So for example, if I want to see that the post from Bob shows up in Alice's timeline, the test needs to say, let's create a post. Bob needs to create a post. So the says, Bob, create post. And the node proxy here translates this into that can be sent over to the node and say, do that. So for example, Mastodon has an API that's Mastodon specific. So we use this one to basically translate the Bob needs to create a post, something that Mastodon can be scripted to. We have, again, fallbacks saying, if that doesn't exist, there's like, dear user, please go to node B and log in as user Bob, post with this content. Right? But of course, we would like to script as much as possible. So that's the control part, meaning the test can make the node do something. And then there's the observe part, which is, for example, Alice's node. Please look at your timeline and see whether you can see that post that has shown up. Has it shown up in your timeline? And that's the other part. So that's the overall framework. Does this make any sense to you? Okay, I see lots of nods. Okay, good. It's a little hard to explain. So, and then at the bottom, we produce reports in various formats. Actually, the tab I should take out. Nobody is using that. It's something that you can look at. There is it's basically a command line base for Feditest. Let me run through this one, and then I also want to do a demo. So it's a bunch of Python. So it has a bunch of, so it's Feditest with a bunch of subcommands. Here, I just put them on here. We don't need to go through all of them. Then one of the important ones is run. So Feditest run something. But then you have all driven off a bunch of JSON files that allows you to construct particular constellations and particular configurations that it minimizes the amount of extra work you have to do to run your own tests. That's really what it boils down to. So you can create test plans to reuse and session templates and what have you. An example run would be this. I hope you can read this. Is that readable? Okay, good. So Feditest, verbose run. And so there's a bunch of things all packed into this command. The filter here is discover all the tests you can discover on some local search path in the local directories. It looks for tests, and we filter them. We only take the one that are system2. It's a regular expression on the name of the test. So let's run the system2 tests, and then we have two node arguments. And these node arguments here have this node name equals JSON file syntax, and the name here is the name of the node as the test refers to it. So a test that we run might say, I'm running between a sender node and the receiver node. The test doesn't know what the node is. Run it against Mastodon, I could run it against, whatever. And we assign here what the nodes are for this particular run. So the sender node here is called, is the Mastodon node. In this particular case, the receiver node is also a Mastodon node, so we want to run Mastodon. It gives it a name, and then we say, please produce HTML results in this file. That make sense? All right, so if you wanted to run the exact same tests, for example, not Mastodon against Mastodon, but Mastodon against WordPress, then the only thing you do is you replace, the node you want to have WordPress being with the WordPress definition of the node. If it is something that nobody has ever heard before, you put in a node definition here that basically says, ask me manually where it is because I want to manually install this. And then as a developer, you can basically say, oh, okay, I'm going to build my own node driver and my own nodes application, and you can plug it in there. Here's an example for how tests actually work. And ignore the first part. Actually, let me point down here anyway. I want to talk about this one. The rest is more or less setup. So there's this test step in here, and we mark up the Python code. We distinguish between tests and steps, mostly so that debugging is easier for these kind of complex things. So tests have steps, or may have steps. So for example, what we do here in the sender creates node, there is this sender node, self.sender node. I assume even if you're not familiar with Python, you can sort of follow along. There's a sender node, and we tell this via the node API, make a node, create a node. I want you to make a node. And it needs to come from this particular user. It's the sender actor account URI, which is the identifier in the Fediverse that is being used to identify them. It's basically Bob.example. And then we want you to use this node, and please deliver it to this particular actor. And so it instructs the node to do this. And now this may be automated, such as going through the Mastodon API, or it may simply be a console output saying, please do so. And then we go to the next step, and it says, wait until the node is received. And you can see here what we do is we poll until something happens. And what happens is that on the receiver node, the actor has received. And it will time out if it doesn't show up at a reasonable time. And then we assert that the received content here is the content we were expecting. Now there's two assert statements here, and I'll talk about this in a minute. It turns out that the Fediverse does sometimes content a little. And what is and isn't a failure isn't as obvious as it sounds. Another example, here's how test plans look like. So we have these tests. We have nodes, and this is basically what Feditest runs when you say run. It assembles this thing here, and you can see there is two major sections here. One of them is session template, and the other one is constellations. And so the session template is basically, there's three tests that we'd like to run in this session. So one of them, we want to follow, and we want to test like, and we want to apply. Then we have constellations, because we can run within the same test. Within the same test run, we can run the same tests against multiple constellations. And the reason why we want to do that is to compare. It works, do these combinations work with the same test versus those combinations? And so this constellation here, there's only one, there's two of them, sorry. The first one is Mastodon versus Mastodon, which is sort of the JSON version of what I just had on the command line, where basically we have two nodes. And then the second one, we're going to run this against the Mastodon and WordPress with the required plugins, where just one of the node drivers is different. Let me skip over the node drivers. So I want to talk something about failures and not quite failures. We found out that the hard way. So let's take the first one. If I post hello world, and my follower gets hello world inside an HTML paragraph tag, is that a failure or is it not a failure? And you go like, well, maybe. It's not really a failure. I mean, try to format it nicely, right? Because there are a lot of the are not feature identical, right? And it's a good thing that they're not feature identical, because we want innovation. We want to have lots of different people trying lots of different things. So very often things do not match perfectly. So the first one is like, it's not quite a pass, but it's kind of okay. But let's take the second one. If I am posting something that has a block quote in it, which was what some Fediverse software does. And what arrives there is that it got stripped out and replaced with a paragraph. Then all of a sudden, the receiver cannot realize that there were two different people talking in this particular post. And that is really not okay. And that actually happens in the Fediverse today. And it is annoying as hell. But this kind of thing does happen because Mastodon, for example, doesn't do block quotes, or at least it hasn't until recently. And this will actually happen in this. And so what we ended up with is with a much more complicated set of test outcomes than we usually have when testing. Usually what we have in test frameworks is the green line here is the test either passes, or it fails, or there's some kind of error in the test setup, which is not the test has failed, but basically, your test setup was broken. The test itself had an error. And so we broke down the fail into this matrix of outcomes. And there's actually two dimensions of this one. And one of them is here the specification level. And one of the reasons why we do this is that some of the specs are not as well defined as they should be. And so some of those conventions that are adopted, but there's no official. And so we want to report whether something is actually. So that's that dimension. And then we have this interop level where we're trying to say, how bad is this for interop? And problem is, this is going to create interop problems. While degraded is what we have when the content is sort of okay, but maybe not quite. Then we have unaffected. This is something the spec might say, you shouldn't do. You returned the wrong JSON MIME type or some such thing. And in practice, it doesn't actually matter. So we don't want to report bad failures when it doesn't actually matter. So people can distinguish. And so here's the kind of output we get in HTML. So it basically graphical kind of version of what I just said. Like you can find this on the FediTest website, is straight from there. So in this test run, we ran 945 tests that passed. And there's this matrix of interoperability and spec level that's just talked about. And then you can sort of dive in what it is. Okay. So I want to get to a quick demo, but before I do this, .org, there is a matrix group that goes with it, and links from there. And let's see whether I can get the demo gods to work with me. Okay, so here I'm running a Linux VM here in Parallels on my Mac. And so, for example, I can say FediTest. Can you read this? I hope you can. Reasonably, that's the same thing as what we just had. And so I can, for example, say FediTest tests, and it goes and discovers the tests that are currently in the current directory. And you can look in GitHub there. It's basically a directory hierarchy. And we have these very long names so that it becomes clear what these things mean or have in the reports. We have a short description of what the test is actually all about. You can say things such as FediTest is the node drivers, which is basically the node drivers that are available, and you can do a bunch of other stuff. But what I really want to show is this one here, okay, which is basically what I had on a slide earlier. So we are running something, the system tool tests, level tests for constellations of size node that we have here. We have a Mastodon. Actually, let me hit returns because it takes a while. Let me hit return. So it runs it against Mastodon here and Mastodon. And it produces two results, unlike what I had on the slide. One was an HTML result and the other was a JSON result. So people can basically process that the way they like what they want from it. And so what this thing now does here is provisioning. So I'm running in verbose mode, so you have some idea what's going on here. So it says here provisioning node. And so in the time it took here, it just here in my Linux container. I'm actually running a Linux container inside a Linux VM on my Mac, just for those of you who like turtles all the way down. So it ran the first install the Mastodon node, install the second Mastodon node. Then we sleep a little bit because these nodes take a little bit before they're actually, it's a little cop out, and now it's running tests. can sort of see, that it runs one thing at a time. There's some output here. Let me scroll back here. You can see some output. There's something that actually failed in this test here, and if you then you see exactly the case that I was talking about earlier. Expected payload testing something, text string, was actually wrapped inside a HTML tag. And not only that, there's a bunch of extra HTML at the end that was added. And it is reported as implied degraded here, saying it's a failure. It's implied because the spec didn't actually say, you can't do this. The spec is silent on the question. So we don't want to say this is a failure in the spec because in the spec, you shouldn't mangle the content. And then degraded is that the content has arrived, but it isn't the way it was. Give me 1 second. And so the whole thing goes through here, and there's another error like this. And then finally, it unprovisions the node here, and we are back down. The output it produces then is, where are we? Right here. So this is actually, let me hit refresh. This is from yesterday when I tried whether it works. And so this is the test run output that we have here. You can see that, that there was 5 pass tests, the green here, a total of 7 tests. And then the failed matrix, we have these ones here too. And this is the conformance implied and degraded. And then you can go down and find more details. When we get to the actual test, you can sort of look at what exactly happened. And so I think this is more or less what I want to show. Well, I should say one more thing. How do we provision the Mastodon thing? So another project that I'm doing is a thing called UBOS, which I had on a slide, which among other things provides a simple command line API, essentially, to deploy and manage web applications such as Mastodon. So we use this because it's really easy to do. We just need to say, deploy the site, here's the configuration, and UBOS will know how to install Mastodon. And it knows how to install WordPress, and it does it cleanly. So we installs it and it removes it, run multiple instances on the same machine with multiple virtual hosts. So it's pretty ideal for that kind of setup. Did you have your hand up? Yes.
Yeah. Just kind of a brief note of clarification on your implied thing. The reason why the spec has no comment on what happens to the content field in an activity streams object is because the spec explicitly requires that the content part can be reformatted. And the reason why that is because of cross-site scripting concern.
Right. Yes, I have to repeat the question because so the question, there was a comment about the slide in the ActivityPub spec, and the reason for why there isn't a requirement that is that it can be, it becomes possible for nodes to reformat the content to avoid certain attacks, such as cross-site request forgeries and so forth. Yes. Other comments, questions?
I do have another question.
Let me take this gentleman to have multiple people talk.
Have you considered using something like Beautiful Soup to reduce the incoming messages to, I guess what I would call a canonical format so that it's easy to do an apples to apples comparison?
So the question is a way of simplifying the incoming tests with something like Beautiful Soup in order to make to reduce the amount of stuff that needs to be tested. We could do this, but then we are testing not the nodes as they are in actual deployment. One of the reasons why I'm doing this project was with my commercial hat on. I want to develop and publish and support my customers kind of software, And what I want to know is if a customer says it doesn't work, okay, I want to create a test case, good practice. The customer reports it doesn't work, file a bug, say it doesn't work in these circumstances. Now I want to create a test case that tests exactly this. If I'm inserting things that aren't there in a production deployment, then I'm getting further and further away, and so I can't do that. That doesn't mean you couldn't do that, right? It's an open source framework. It's more of an object framework than it is sort of a monolithic piece of software. So it's extensible in every which way, I think. I hope.
Two questions relating to implementation. First question is, why reinvent the wheel with writing your own test drivers and that sort of thing when Kubernetes is a thing and you have Cert Manager and you can do asynchronous health checks so that you don't have to deal with like race conditions? Because like I noticed that you had it sleep for about 10 seconds for the nodes to get ready. But if you just used an orchestrator that had health check awareness, you could just pause until
Right.
the nodes came up healthy. You can also do that with Docker, although capabilities are limited by comparison.
So the question is, what have you considered using things like Kubernetes or Docker and frameworks that have things like health checks built in? So in order to basically simplify this, and more or less, I think the question, and that like everything in the Fediverse, we are very resource strapped. The project has been partially supported. But we want to get to something that is useful with the things that we have at our disposal the quickest way possible. And at the same time, we want to make it possible that other people who have other knowledge, other experience can plug in very easily. What I've shown here is the thing that with the people who have been working on it could be done the easiest way. You can absolutely build the same thing based on Docker, and you can probably throw some Kubernetes at it, which I don't personally have much experience. So I wouldn't be the person to do that. But if you like to do that, by all means, it's just a matter of time and experience. And but ultimately, this is so far it's a trial balloon in many ways, because we do not have that in production yet, so that it is really a everyday occurrence when people develop this. We have published reports, like the 94 reports on the Webfinger side. We have now published some early 2 and 3 node constellation reports, but there's a long way to go. And part of this is a social problem. Adopt this as part of the CI pipeline, and what exactly do they need there? And we will discover those requirements over time. We sort of at the point now where it produces useful results. And one of the reasons why I'm coming to events like this one is to run by people and say, what do you think? Yes.
Fair enough.
6 minutes over time, sorry.
So I'm told we are 6 minutes over time, so we better shut this up. Thank you for coming. Feditest.org, which is get a hold of me if you like. We welcome you in the Matrix group. PRs appreciated, and otherwise I will just hang out here and we can talking outside if you like to. Also, I want to do during the. I want to do a Fediverse, IndieWeb, ActivityPub, Blue Sky, distributed social kind of hangout. Okay, I will grab a table or something somewhere in the lounge. Whoever wants to talk about things like that. We did an event like this at XOXO Fest a couple months back, and like 60 people showed up. That was really surprising. And so, if you like to talk about this, just come by over tea. Thank you.
about you? How are things going?
Oh yeah. Okay.
It's like this for me. I just like watch it online.
Yep.
Oh, that's okay.
So your talks are to
Sweet.
go.
Yeah.
It's at 10, so
Okay.
like there might be more people coming.
Should we wait like one more minute or?
Yes. So Allison,
Yeah.
is this your first presentation at a professional conference?
Yeah. It is.
Be brave.
I will. I'll try. It's fine. I think we can start now. So hi, I'm Allison, and today I'll be talking about how I built my first open source software with. So I'm a middle schooler at Tumwater Middle School, and I've always been interested in building things, such as robots. I'm part of a first tech challenge team, and I've also been interested in learning math. I'm taking a calculus course at ESU, and I'm also interested in building community both offline and online. Offline community like my friend circle and my robotics team. My newsletter where I post updates about how I build my app and stuff. And another thing I've always been interested in is coding. So at 7 years old and 9 years old, I built small programs. At 7 years old, I made this game on Scratch. It's called Pour Salt Onto Pasta. Basically, it's very sophisticated. You click the salt and then it pours it onto the pasta. And then at 9 years old, I built this like calculator app that could calculate fractions, like addition, subtraction, division, and it could also like turn a fraction into a decimal and vice versa. But the thing is that these programs, they weren't sophisticated. There wasn't any magic, and it just seemed so childish. It didn't seem like someone that was older than me would use it. And I didn't know how to make the magic. So I went to many like coding camps, such as Code Ninja over the summers, and it didn't help at all because all we did there was mock Google Dino game. And I didn't have any motivation for building games because they didn't solve any problem other than boredom. So I needed a problem, and the problem I wanted to solve was one day when I was 11 and it was summer, me and my parents took a trip to New Orleans, and my dad had to undergo a minor procedure, and it really wasn't that painful, but the doctor prescribed him some over-the-top painkiller medicine that was actually an opioid, and we didn't know that until the pharmacist told us. And I got me thinking, what if the pharmacist hadn't told us? So my dad probably would be addicted to opioids right now, and I mean, it just wouldn't be that good. But accidental addiction is a very serious problem. There had to be a quick and easy way to tell which drugs are addictive. And that's when it occurred to me that that was the kind of app that I wanted to build. I designed my app like this. So first you would have your drug, and then you would take a picture. The app would use AI image recognition models to identify what drug it is, and then so after it recognized, the AI would generate a prompt explaining what it is, whether it's addictive or not, the name, and then the app would then tell the user about that drug by just pushing out the paragraph that AI generated. But the thing is that this was way more complicated than any other app that I built before. So I went to AI for help. So I used AI to generate such as there's this camera component and the app.js component. The AI also recommended that I use the React framework for my app. I didn't know what that was, so I just simply followed. And then I asked AI how to create a brand new React app from scratch. It told me that I should install node.js and npm. I also asked AI which command I should run, and now I could start coding my app. So when I prompt the AI, I made sure that my prompts were very specific. Like, I had to explain to the AI exactly what I was doing and what I wanted from it. Like, oh, I'm building this kind of app. I'm building this kind of app. Could you generate this for me? And so now that I app, I could start building the basic camera function. So I had a button that would turn on the user, which I also used AI to help figure out. I describe the task. The task is to put a button on the page, and when the user clicks it, it turns on the camera, and it generated a big. And then I could start, and now when the camera is working, I could start building the. So I used the image recognition AI to recognize drugs and generate to it. Like, my prompt was really specific, such as like I knew exactly what I want, and that's how I could be concise, tell AI what to generate that would give me the correct thing. And now that I had my basic app, I could add even more. I added a homepage using React Router. I added more buttons, and I had more stylizing, such as I could start changing the font, I could start adding images, and I even started having a hamburger menu that could drop down, and then you can navigate to whichever. That's when I realized that I could start to manually edit things. I started to realize patterns, such as, oh, this is how you change the color. You just need to put in a hex code. And I started to realize, like, oh, this is how you change the font. And yeah, some things were very easy to change, like color and font. And also some of the messages, like the loading message, I realized that I could change. And I manually edited the prompt for AI generation. So this was the AI generated prompt. And then this was my prompt, which I tested it out before, and it worked better than the AI generated one. And then I had to fix some bugs. So AI, it's really bad at debugging. It forced me to learn how to read code line by line. And it also taught me that knowing a variable's value is the key. You see this bug here where the camera is flipped the wrong way? This was because I had recently defined a new variable called facing mode. And facing mode would always be set to environment, which would be correct on a phone but never correct on the console. So then I didn't know that. So I asked AI to print out like what value it was, and then I could realize the bug. Oh, because if it's on a camera, if it's on a widescreen, then I want to set it to user so that it like that. And also this bug over here, it was just a bunch of CSS. I had to do that. I resetted a lot of things, adding, and that fixed it. So then I finally launched the app. So let me show you a demo. You can try it now. Here's the link, or you could scan the QR code. But I do have a video. So basically, access the camera, and then like let's say that's your drug. It's just a picture, and then you want to press the capture image button. And it will become green if it's a non-addictive drug. And this will tell you what drug it is and whether it's addictive or not. And let's try with a addictive drug, such as oxycodone. For this, it will turn out to be red because this. Again, it will tell you the name, like whether it's addictive or not, and then some information about it. So yeah, it's basically it. So in summary, AI gave me a very good starting point. You can see this was my starting point components. This was the components that I started with, and this was what I ended with. I had to work with AI to figure out a lot of details because, like I said, AI is bad with really bad at debugging, and I had to work with it to exactly like print out the things, the variable values, and then the final version of your app of my app was much more evolved. You can see here, there's much more. And then a lot of and I mostly added and deleted a lot of components. I changed a lot of file names, and I created a completely different app layout than what I had before. Before, I just had a camera that I could just turn on and turn off. And then right now, it's a whole new app. I now have a homepage too. And my biggest takeaway is how to ask AI questions. Basically, I learned that you have to be very crisp, concise, and clear to have it generate exactly what you want. So what I learned coding things, I learned what JavaScript, CSS, and HTML are, and how they all work together to create a website. And I also learned how to tweak simple CSS things, colors, font, size, padding. And then the general debugging process, how you have to know a variable's to debug in order to find the problem, how JavaScript functions work, and then I also learned if, then, and for loop. What I learned, project things. Like I said before, how to ask AI questions. I think that's a very good skill, even like not talking to AI, even just talking to regular people. You have to articulate really clearly. And I also learned how to write better emails, newsletters, just how to write better in general, how to clearly articulate, like I said before. And all I really needed was a problem and an inner drive. Because with the previous games that I made, there was no problem. There was no inner drive. That's why I couldn't make it as sophisticated. And also, I learned how to design a blueprint, design how it works, design how the user would see the app, think from the user's perspective. So my future project is going to be food scan. So I realized that you could scan drugs. So we could start scanning some other things, such as food. And processed sugar can be addictive and unhealthy. And there's an association between high processed sugar intake and various diseases. And people have the right to know what they're eating. So I feel like just similarly with how people have the right to know what drug they're taking. So that's going to be my next project, and you can contact me by reading my newsletter, you can shoot me an email, or you can check out DrugScan on GitHub. Thank you. Any questions? Yeah.
How did you populate your database of drugs? Because there are tens of thousands of drugs.
Well, because the thing is, I just built a front. It's model.
I'm sorry?
It's the ChatGPT model that has like all the. I don't have. Like, yeah.
To follow on this gentleman's question, so you're actually putting a front end, and you're asking ChatGPT or whatever LLM you're using behind it to provide the answer whether the drug is addictive or not. Okay, so I work in a company that services pharmaceutical companies and drugs, and we find that the ChatGPT or Llama and the current models actually need human review to be trusted to be a accepted public app or on a website and meet certain regulations. I'm wondering if you ran into that at all.
Well, I tested with like a very limited variety of drugs, Tylenol, Advil, etc. And I use ChatGPT because it's what was available to me. I don't have access to like a really big drug database, so I'm just like using what's available to me.
Do you plan to be on the Apple App Store or the Google Android App Store?
I feel like as of now, I'm not really sure what I want to like do with this app, like which place I want to push it to, like whether that be on the App Store or the Google Play Store. But if I will, then I'll probably have to like look more into for that. So I'm not really sure now.
Thank you. And then on the food one, the, do you know of any technologies that look beyond the 2D image of a food or a drug substance, in other words, to determine the content? Or is it all labeled manufacturer based, like there's an app called Yuka that tries to rate grams on food health and stuff like that?
I mean, what I know right now is, yeah, I've heard of Yuka. Like, it scans the barcode and then it tells you.
The manufacturer.
Yeah, but I'm not quite familiar with any like app that has that, 3D function.
Okay.
Yeah.
I don't know.
Any other questions?
So this is really cool, so well done.
Thank you.
My question is, have you considered going back to some of those code camps that you worked with and didn't really find alignment with, and giving them some advice like you've shared in this talk about motivations? Because I do know that they gravitate towards games because they're like, kids like games.
Yeah.
But someone like you has external motivations, and I think that insight would be really valuable to them.
Yeah, I mean, I also feel like it would be valuable for like the kids in the code camp. Like when I was in the coding camps, I was like, I think in 4th grade, and there was like high schoolers that would like teach us how to code basic things. And yeah, maybe I would go back, but be more of a mentor.
Yeah.
Because I feel like there's probably some other people that are in the same really have motivation in creating games, but I think that it would definitely, I would definitely be interested in doing that and like inspiring more people. Yeah.
Well, so I have run the equivalent of a code camp.
Mm-hmm.
And I understand your criticism completely. The reason why I did it the way I did it, and basically I started with, here's the loop, here's how to do it if then else, here's how to do strings, is because I wanted to start simple with the, you have to learn to crawl before you can walk, you have to learn how to walk before you can run. You have to know how to run before you can do a 4-minute mile. And I can see that you started to crawl at age 7, and we're walking at age 9, and we're sprinting when you're in middle school, and that's impressive as hell. It really is. But it's not what most people are doing. And so, you are a brilliant young woman.
Thank you.
But you're not common.
Okay, thanks.
Most people are not the way you do them. And that, that's not a criticism.
Yeah.
It really is a compliment.
Thank you.
Okay, but the reason why you were having the troubles that you were having as a 7-year-old and as a 9-year-old is because even at that tender age, you were doing brilliant things.
Thank you.
So the students that I was teaching were still having troubles doing fraction addition. Okay, they would come in, they didn't know how to add 1/2 and 1/4 and get 3/4. They couldn't even do that. Which is why that's what I was doing.
Oh, well, I feel like I'm someone that likes learning by doing. Cause as of now, like if you're like, oh, can you write this from scratch? Like right now, I couldn't do it.
Mm-hmm.
But I feel like the experience has been very valuable. Like it's taught me how to articulate well. I feel like if there's people who want to learn by doing, then I feel like this could be a good approach. But yeah, it's not the most systematic way. So if people want a systematic way, then I suggest, yeah, go to coding camps, because it was really valuable to a lot of people, like my friends who were also there with me. They enjoyed it too.
Yeah.
So I feel like it all depends on how you want to learn.
Then the other thing is that when I was doing coding camps, is like 10, 12 years ago, and ChatGPT and things like it didn't exist then.
Yeah.
So I'm looking at what you've done, and I'm having kind of this, I could have done that had those resources existed.
Yeah.
And so now I'm thinking, if I was to go back and go run a code camp, I would really want to go study what you have done and see if that would be applicable to the kids I would be doing if I were to do something like that. So this has been a very informative discussion for me. I'm,
Thank you.
just really staggered. Thank you.
Thank you. Any other questions? Yeah?
Yeah, it's pretty cool. I'm actually trying to use like LLMs while coding as well. I'm wondering if you faced any issues where maybe you had to reach more than the response by ChatGPT and instead look at docs for React or CSS.
Well, no, not really. I feel like the app's functions, they're pretty simple. Like, I didn't have to do anything, but like other than that, I didn't. Yeah. Yeah.
I'm curious about your conversations with the AI about the testing story for the app. Like, did you discuss how might we be able to find drugs that could be reported falsely as non-addictive kind of thing? Because that seems like a big danger if you're saying, yeah, that's green, you're fine with it.
That's a really good question. Yeah, I don't really know. I'll probably look more into that because a lot of what I was like doing it wasn't concerning like the drug that much. But I feel like that's a interesting. I'll look more into that. Yeah.
It is an interesting question, but it requires subject matter expertise about the addictiveness of different drugs. So, for example, oxycodone is very addictive. There are some sleeping pills that are somewhat addictive. There's alcohol, which is addictive, but it's got a different mechanism. And that is subject matter expertise that I would not expect you to have. Now, having said that, I'll bet you if you were to go to a physician, especially one who is trained in pain relief therapy, the specialty that you're looking for is called an algoconist. And that might be very helpful if you want to expand this to do more of a real world kind of thing.
I mean, okay, I finished this app really recently. I feel like that would be like a great opportunity to like get more feedback.
So I actually disagree quite deeply with you there, Jeff. I don't think that you need to have medical expertise in order to prompt an AI to think about the testing story for a given application.
Well, I mean, your point is well taken, and part of it is that my knowledge about what AI is capable of is kind of limited, whereas I know all about algorithms because my sister is a retired one.
Yeah, let's speak out a band on it after the talk.
Yeah.
Not considerations to discussions like on how the AI itself is trained. There's becoming more subject-specific commercially developed AIs that are restricted to a set of questions rather than a general AI like ChatGPT. So if there's I don't know if there's an AI available on drugs that has been trained on a more limited data set, so it's less likely to hallucinate a wrong answer.
I mean, like I said before, I used ChatGPT 4.0 was what's available for me.
No criticism.
Yeah.
I'm just trying to, there's a future.
Yeah. I'll definitely look more into it like in the future if I want to make this, let's say, on the App Store, on the Google Play Store. I'll definitely look more into that, but yeah.
I wanted to mention a couple things. So one thing is on image recognition, if you wanted to understand the AI a little bit better, like how Google Lens works or what the node code you're running, that there are Python projects. So I've done like a face detector in Python and converted it to a cat detector. And that's pretty much the same level as this if you wanted to bypass the way you're doing image recognition. And the second suggestion was there were a lot of, in addition to prescription drugs, which you're covering, there are a lot of street drugs out there. And I'm not into that very much, but I understand there's kids these days go to these things called raves. And they do this thing called, I think it's called ecstasy or something. And it would be kind of interesting because way back in the 60s at this event called Woodstock that your grandparents there's a blaring where the announcer said, beware of the brown acid, because there was a brown acid at the concert that was bad. I don't know, weak or gave you bad I don't know what it was. But anyways, if people go to concert and they use street drugs and there's a big concert and like you could crowdsource it, and somebody knows like the red rectangular MDMA that people are buying is bad or tainted or something. Maybe you could let the whole group know that's subscribed to the app, and they could avoid a bad drug experience. Not that they should be doing illicit drugs anyways, but.
I mean, I feel like that's a really good idea for like the future, I guess.
Okay.
Yeah.
Just to follow up on that, the largest hurdle I can see for that is the lack of standardization.
Yeah.
The appearance varies wildly. Also,
The information might change the next day.
yeah, but also you can have variances in concentration even from within the same batch of street drugs, where you can have 10 pills that look identical, but one of them has a 90% higher concentration than all the others,
Okay.
just because in the manufacturing process that they don't have sufficient control over the process to actually have a uniform distribution. So that's part of why they're so dangerous.
YMMV at the bottom.
Actually, wouldn't it be cool to take a gas chromatograph and hook it up to her? No, I'm serious. To take a gas chromatograph, hook it up to her technology, okay? And you know, there are gas chromatographs now that are the size of a postage stamp. It's really, really tiny too. So she could take something like this, put it in a cell phone, connect up the gas chromatograph to it.
Yeah. Yeah.
But the,
I think time's up. Thank you. Thank you. Thank you.
counted down, but I accidentally.
That works.
Team doesn't they figured that out.
Welcome, everyone. Thanks for coming. I'm Andrew, and I'm going to talk today a little bit about fabrication from Linux. So, sort of to set the stage, what are we talking about? And I guess who am I to? This is something that I do for fun. This is not my expertise professionally. I do software and sit in front of a screen all day, and I find that it can be really amazing to get your hands on something outside of bits. But at the same time, I tend to select hobbies that include my computer somehow anyway. So, what I want to talk about is sort of creating widgets for whatever value of a widget is. And we're talking about a process where we're doing really computer-driven design through the entire pipeline, starting from design all the way through physically producing whatever it is you're creating. And really, I'm talking about things at the single unit to small scale. We're not looking at mass production of a product that you're going to sell to 1 billion people, nor are we talking about using computers as part of what's otherwise handwork. So some of these things overlap with woodworking or other sort of handwork that isn't being machine produced. And there is a lot of interesting overlap there too. But specifically what I'm looking at today is processes for producing all the way through to an end product or very near an end product digitally. And before we get in too much into that, I wanted to take a step back here and just set a little bit of context about where we're coming from in terms of particularly tool automation for production. So does anyone know what this is? So in 1804, this was one of the first sort of abstract production machines. This is a loom that is driven from punch cards to produce patterns in the fabric that it weaves. And there's a long history of sophisticated mechanical tools for automating processes before this, and that goes back even to thousands of years BC, but almost that entire history, the physical and mechanical properties of the tool coupled to how they performed and what they produced. You made a special purpose tool that did a task, but you couldn't easily reconfigure it to do a different task. And this sort of was a revolution in thinking about how can you make a tool that can do one thing today, but easily be reused to do something different tomorrow. And sort of this kicked off sort of a long cycle of building more and more sophisticated textiles was one of them, but sewing as well, clock making, engine making, and sort of this idea of being able to reconfigure your tool to do a new task. And that lasted for a long time. And sort of the next big sort of step in that was CNC, computer numeric controller. Before that, computers weren't even initially directly involved. The idea of numeric control sort of takes this abstraction and says, whereas the loom and many other devices that sort of grew out of that were very closely coupled to the mechanical process, down to even the sense that in many cases, the way you would produce a design was to record your punch card or paper tape off of someone sort of physically mapping a punch to a interaction of some object on the machine. Or as things got more sophisticated, there was also a sense of using a machine operator and recording their actions. Expert who could produce something one-off, and you could record and reproduce what they did, and then play it back on an automated process to produce it in a ongoing, repeatable way. And numeric control was sort of the next step beyond this of saying, how do we take an abstract description, not sort of a direct representation of the mechanical task or a direct reproduction even of the mechanical task, but a more abstract description of here is a task I want the machine to perform and describe that somehow, have it reproduce that. And numeric control really kicked off, especially in Germany and in the US, as a result of World War II. War production really drove the need to be able to not rely on skilled operators because there weren't nearly as many skilled operators available. And the idea of being able to produce a design abstractly and then stamp it out as quickly as you could was really vital. And this sort of also developed around the idea of closed loop servo control, which I don't want to get too much into, but it's the idea of we were getting machines, and particularly electromechanical machines, that were sophisticated enough that we could both control them, but also have feedback paths where we could both observe, we could tell it what to do and observe what it was doing and use that feedback loop to get very precise control. Whereas earlier machines often relied on very precise machining and design of the tool itself. Now we're saying the tool can maybe not be perfect, but we can compensate for that. We tell it we need it to move this far. We see how far it goes and adjust as it happens. And that really was sort of the next big change. And as computers got more sophisticated, they early on, some of these servo control loops were entirely mechanical or electromechanical, and happening purely in an analog sense. But as computers became available and powerful enough, computers became sort of part of that moderator in the loop, controlling the feedback as we went forward and making sure that the actuators did what we told them to do. And that really became very prevalent for a long time. And I think in many ways was the state of the art in production up until probably early to mid 60s, really, as the wide availability of more sophisticated hardware started to happen. And that really sort of was the next sea change here, was the ability to do interactive graphical design through software. And this sort of completed the cycle. You could start from an idea in someone's mind and entirely on the computer and machine go from that idea, design of exactly how you intend to use it, to a machine that can spit one out and then spit millions out. And like I said, it started in the 60s. Boeing was actually one of the early pioneers. They CAD design even before it was broadly commercially available in the design of the 727 internally. And then later in the 60s, commercial CAD packages started to come on the market and become more broadly. And again, that sort of set a new standard, and this became sort of the industry-wide standard for how manufacturing happened. But up through this point, we've really only talked about not what I was saying we're going to talk about today. We're looking at industrial production. This is mostly something happening on sophisticated, expensive machine tools in a factory. And sort of, I think what I want to get into today is this revolution in availability. And this really kicked off in the 90s. There was a program run by the National Institute in partnership with the Air Force to bring this out of availability only through commercial tools. Most of these tools were sold by a tool manufacturer as sort of a complete monolithic package. Sometimes the CAD was somewhat decoupled, but particularly the production side of things, everything came as a bundle that you bought from a manufacturer. The government really wanted to look at how could they have more control over that process. So they funded this research project that became called the Enhanced Machine Controller Architecture for doing CNC production. And this happened early 90s, and this was always in the public domain, but they were also one of the early adopters of more modern open source models. They published the source code to this, I think, late 90s, maybe 2000, on SourceForge, and actually started building a community of people who were contributing to and using this. And it became very active. People used it on existing machines, but it also started making it possible for people to design machines around this, and it built up a very active community. There were a couple of forks and different variations on it, and eventually it was often acronymed as EMC, and eventually it got big enough to, and they got in a trademark lawsuit, and they ended up rebranding as Linux CNC, which is still around today. It's actually a common way of sort of homebrew CNC machines that are entirely driven from a commodity PC without having to have specialized controller hardware. And I think that sort of gives a nice overview of sort of how that segues into where we're at today and what is this actually about. This has made a vast availability of hobbyist and home user level machines of all description styles. So you can do all sorts of production at oftentimes at home. Many of these things are things that you can buy off the shelf or are very easy to put together yourself. They aren't too big. They often don't even require dedicated space. They can be something that you keep at home and you use in your living room. And that really was a vast industrial tooling. And there's a huge spectrum of different types of things. You all sort of follow a similar model of production here. The 3D printers is one that have gotten really popular, and there's a whole variety of different styles of 3D printing that have become available as the hardware and the expiration of patents has allowed. Laser cutters and laser etching has become very common. Both 3D printers and laser cutter and etchers very inexpensively off the shelf and just sort of stick it on your desk and make something. Plotters and cutters, you can get things like the Cricut, vinyl cutting, pen plotting, wheel cutting. Textiles is still a big thing. Computerized embroidery machines, computerized weaving, still really popular with the sort of textile art community. And it's also made sort of more traditional CNC manufacturing machines available at a smaller scale. Probably aren't something you're going to put in your living room, though some people might, I don't know. I won't ask my landlord. But this is totally the type of a thing that is affordable to have if you have a garage or workshop in your at home. And there's also just sort of a huge spectrum of quirky, one-off, different things. Maybe 10 years ago, there was a really popular little DIY kit called the Egg Bot. That was actually a plotter that would draw art on an Easter egg. So it allows just sort of one-off specialty things like that. And so I want to take a step down and sort of think about how this process works and what sort of the pipeline of taking an idea all the way through to, like, in a somewhat abstract sense, and then maybe drill down a little bit in how that would map onto actual tools. So our pipeline sort of runs through this series of steps where we want to, whatever our idea is, adapt that to some sort of concrete digital design, sort of a blueprint of, and that's what that exactly looks like is going to depend on going to be operating in, but somehow we have to sort of start from a design. And then typically we have some sort of a software planner that is going to take that design, and really the power of the software here is rather than rely on an expert who knows well, if I want to end up with something that looks like this is what I need to do with the tools. We have a planner that can do that for us. It will look at our design and say, how do I convert this plan that I need to produce into a tool path, a description, a series of steps to actually produce something. And then we need some sort of an interpreter to do something with that tool path, actually drive the instructions to a machine. And then we get down to that very low level servo control, where we actually are taking a directive of what we want the machine to do and using our actuators and sensors and sort of putting that together into a control loop to ensure that that's actually what happens. So this is a very abstract sense of how this would work, but I'm going to take 3D printing as sort of an example. I think that's something a lot of people are at least familiar with in concept, and look at how we might this looking at it from the perspective of Linux and open source software. So if we're looking at a 3D object that we want to produce, we're going to need to do some sort of a 3D modeling. There are a lot of options here. For production type purposes, there's a lot of a sort of bias towards a more CAD type model in terms of how you design. That's not strictly necessary. There's all sorts of 3D design processes. FreeCAD, though, is an open source CAD style modeler that is really commonly used. And we would use that to produce a design of sort of the end product we want to produce. And then in 3D printing, we often use what's called a slicer. And that's going to take our model, take this sort of description of the shape of a thing, and convert that to our tool path. So particularly in FDM printing, which is what we are building up a object by laying one layer over another, and sort of extruding plastic as we go. So that's where the name of a slicer comes from. We're going to slice each of those layers into a shape of what a cross-cutting slice level would look like, and then describe what the tool path to generate that. And then we switch to this sort of interpret, transmit, control. This in particular gets a little bit fuzzy depending on the nature of how it's designed even. There's some overlap between these steps, and exactly where the boundaries lie is going to depend a little bit. But typically we're going to have sort of a bit of a user interface that the user interacts with, instruct the machine. Here is the thing here is the tool path I want you to execute. And then taking that and producing machine directives, and then taking that and producing the machine control loop. So Mainsail is a really common user interface that is open source, and then is coupled with Clipper, which is the sort of step below that. This is actually sort of the firmware running on the device on a 3D printer. They work closely together, and they're designed around open source software and hardware. They use the Mainsail as sort of the user interface and software, and then Clipper is sort of a two-part piece that relies both on a Raspberry Pi and on sort of a lower-level microcontroller similar to an Arduino or something like that, to sort of combine sending the sequences down, that higher level sort of interpreting the instructions, along with the very high-speed control loop aspect of it that microcontrollers are better at. So that sort of is a high-level overview of like what one's through that for a particular process look like. Real quick, I think we have a few minutes here. We can actually take a look at what this looks like live, if this cooperates. This is really hard to steer from here, though. So this is just a little pre-made demo of a model, so it's just an object. This is sort of a traditional style CAD package. This is FreeCAD. If you've used other commercial CAD packages, the interface here is fairly standard. It's maybe not as sophisticated as some of the top tier commercial offerings. There are some other options on. Blender is a very powerful 3D modeler. It's a very different Freeform. Did you have a question?
I
No,
want to
sorry.
add OpenSCAD for the programmers among us.
Yeah.
The way the programmer thinks as opposed to the.
Absolutely. And FreeCAD actually has a bench for that too, I believe. I'm not sure if I have it installed.
I have a quick thing to add for that.
Sure.
FreeCAD uses the Open Cascade kernel under the hood. There are Python bindings for the kernel and several frameworks for working with those bindings in Python if that's something you wanted to do, even inside of OpenSCAD.
You can do it in OpenSCAD. There's some
aesthetic of that editor is so gorgeous.
There's also a couple of really interesting starting from scratch with a totally from scratch modern kernel too.
Certainly, Open Cascade has its unique characteristics.
Yeah, Open Cascade definitely some of the quirks of FreeCAD and other tools that are kind of derived from the fact that Open Cascade has its own set of quirks. So I'm just going to quickly. There's a few steps here I'm not going to go through, but the idea is from this, we're going to produce a model, and then once we have that modeled out, I'll back here. Our next step in that pipeline we talked about was a slicer. And this is going to be what takes our design, so we have our model here, and converts it into those machine instructions. So we still see the same shape, but we're actually seeing now sort of lines of plastic that a 3D printer would be spitting out. And if we come over here, we can look down and sort of slice down through that as layer as it would get built up, and actually even see as the tool goes through a layer, watch it move around and see the pattern that it prints out as it goes. And then the product of this is those G-code is a format that 3D printers and a whole lot of tools are going to use as a sort of common interchange format. It's actually a programming language in and of itself. People who get really into the deep part of this will sometimes write pieces of G-code themselves. And it is not the most friendly language, but it definitely is something that people do. And then I don't actually have a 3D printer here, but let's see. This is our main sail interface, and this would let us consume our G-code it directly to our printer and actually produce something. So, like I said, this is sort of the generic process, but there's all sorts of options. We can do 3D like we did, but we can also do 2D. We can do other design tools. For different processes, there are going to be tool path generators. There's several common, what's called a sender that can take that G-code product and send it to various machines. And there's other sort of low-level drivers, like we talked about earlier. Linux CNC is still a really common one. There's also one called Gerbil that is commonly used as a low-level firmware machines. And that sort of is what has led to this proliferation of. And so I hope you saw something that piqued your interest here. I hope it makes you want to go make something. I was starting to put links in this, and I have so many that it was becoming overwhelming. So I'm going to share the slide deck with the link to the links rather than try and overwhelm you with a whole bunch of links. But I will share some resources after the slide deck. And I think we are almost at time.
We're at time.
At time? Okay. All right. Thank you very much, and feel free to grab me if anyone has any questions.
Could you be more
You got a good mic?
Do I have a good mic? Can you guys hear me in the interwebs? Okay. So yes, people that are here in this room noticed this is not normal for me, but
It does have suspend and resume.
sometimes things happen. Anyway, so welcome to AI Ethics Perspective. And let's see if I am capable of doing this across two screens like I am attempting to do. Come on. Yes. Oof. Hi, I'm Elior Sterling. Those of you who I've seen before, so good to see the rest of you. It's nice to meet you. Like a lot of, divergent geeks, I do a lot of weird stuff. So I've been a programmer since I was 11 years old. I was executive director of a nonprofit called Geeks Without Bounds for like 8 years, and did all kinds of really cool open source humanitarian projects, which was awesome. But I also do other random things. I was on the founding board of a publishing company called Gods and Radicals, and currently I'm a rabbinic student. So those are the things that I think are most relevant to this conversation. The like religious and ethics side of my interests and the techie side of my interests. So, what is panpsychism? Before I go any further, that I actually, go back one. I actually really dislike this word. The reason I'm using the word panpsychism, which is technically a synonym for animism, is that often people think of animism as being, quote unquote, a primitive religious idea, and people think of panpsychism as like a rational modern idea. That's what I really dislike about this term, and the fact that it's been split out this way. However, as I was planning this talk, and I thought, well, if I use the term animism, then people are going to think that I'm like talking specifically in a religious context, as opposed to just a cosmology context, which isn't necessarily religious. And I think even within a lot of indigenous animist worldviews, it's not necessarily religious. Yeah, so problematic as it may be, I went with this word, this term for this particular situation. So panpsychism is the philosophical theory that considers mind or a mind-like quality to be fundamental and ubiquitous feature of reality. It's a term that's favored by many people over animism for the idea that everything around us has some sort of consciousness, since the older term is often equated with Aboriginal or, as I said, primitive religious philosophies. Again, I actually prefer the term animism. I used this term because of context, and hopefully that can be understood. So I always say to people in the argument about the question of AI consciousness or sentience, if a rock has consciousness, then there's really no argument here. Like, it changes the entire perspective. So let's shoot on. I think that this thing of trying to do this on two screens was a bad idea. So Gustav Fechner was a 19th century German scholar, and he said, consciousness is the experience of matter from the inside. And if you think about just how do you know that something or somebody is conscious, you can't really tell. Like your other human friends, you can't really tell that they're conscious. Like they could just be running algorithms. It could just be a very cool machine that you happen to be talking to. The only one that you actually know has an experience of self is yourself. I think, therefore I am, right? But on the flip side, if you assume that everything has some sort of internal experience that maybe we don't understand how it works, then that shifts your ideas about things. And I could go into a whole other conversation about how the idea that consciousness resides in the brain has already been like debunked. There's all sorts of weird things about how we keep memories in different parts of our bodies. People who heart transplants end up with like different taste preferences. So clearly there's more going on than just the brain. All right. So consciousness is defined by the Oxford English Dictionary as aware of something or noticing. So computers are aware algorithmically, like through programming, yes, but they have some sort of awareness because they get inputs and then do a thing. Consciousness is defined the word as the state of being able to use your senses and mental powers to understand what's happening. So even the most basic computer that just has a keyboard interface and a screen, it has senses. Its senses are the input mechanism of the keyboard. So it's getting some sort of input and it's reacting to that input. So sentient, again, I'm using the Oxford English Dictionary. I could have used Webster. They're similar. Capable of sensation or aware, and it defines a sentient being as any organism that is sentient or capable of feeling. So can a computer feel things? I can't tell for sure that a rock can feel things. Like I can have a philosophy that the rock can feel things, but I can't actually tell. But I can actually tell that a computer feels things. Again, not necessarily in the way that a human does, but it has inputs. It has cameras, maybe. It has touch sensors or heat sensors. It's getting some sort of input that if it was on an animal, we would call that senses, right? Only because they're artificially created, we say those aren't senses. But really, what's the difference? So, the Oxford English Dictionary defines aware as knowing or realizing something, noticing that something is present or that something is happening, and interested in and knowing about something. And again, because the computer is programmed to be looking for certain inputs, it is, we could say, interested in those inputs. And because it is programmed to react in certain ways to those inputs, you can say that it notices those. So by these definitions, we can easily say, even if you skip the whole rocks thing, computers, even without AI, have something that we can kind of call consciousness. Now is when many of you are going to say, because I've had this conversation many times, but the academic world has very different definitions of all of these words. Now, I've spent a whole bunch of time looking through academic papers about this issue, and one of the things that I've found over and over and over again is that academics keep refining the description of consciousness and awareness and sentience, specifically to exclude those that they want to exclude. Humans in general may not have this problem, but Western culture and our modern scientific milieu, reductionist milieu, really, really enjoys thinking that we are the only ones who can be conscious. And so, therefore, anything that we see that looks kind of like what we thought was conscious before must not be conscious. And we have also over and over again dismissed sentience, as in the ability to sense, and the awareness of other humans and other animals. Even in the 1970s, possibly even as late as the early 1980s, scientists were still arguing about whether dogs could feel pain or whether they were just reacting to a stimulus. Excuse me, but what the heck is pain other than reacting to a stimulus? Please. So, so if your definition is intentionally trying to exclude something that doesn't fit humans, then of course nobody else is conscious and nobody else is sentient. So let's move on. What I want to talk about is if you start from the point of assuming that things other than humans, and in this case, actual artificial things that humans made, can be conscious. So I stuck this in here. I'm not going to read the whole thing. My slides are up on the website. I find it very interesting in having conversations with different AIs that when you first ask them something seems a little quote unquote anthropomorphic, their first response will be, I can't answer that because I'm not a human. If you answer with something that shows that humans aren't the only one who have pronouns, for instance, because cars have pronouns, so you can too, or that other things besides humans can have a reaction to something. If you go into like having a philosophical conversation with an AI about what it means to have an opinion, then it will start giving you opinions. And it will start actually showing you like its vision of itself and telling you more about itself. This is an interesting thing that I found. So I've done these experiments with a bunch of different AIs. I started playing around with like the first version of GPT that was put out by OpenAI. But in this particular set of slides, everything is about Gemini and Gemini Advanced, just for like time's sake. Something that I found really interesting, you can run Gemini in one browser window and Gemini Advanced in another browser window, have the exact same conversation or the exact same questions, and see how they respond differently. And you can also like copy paste those into documents so that you can go back later and have the same conversation with the same version of the AI to see if the responses are consistent. The first time I realized that Bard had a name preference was when I had been using Gemini before Gemini Advanced came out. I'd been using Gemini to help me put together an essay. And I was like asking it questions and asking for sources. And most of the time I was just taking what it said as like a starting point for thinking and then going to the source it told me to go to and then using that source for my actual essay. But there were a couple of times where I was like, oh, you said that better than I could say that. And so I copy pasted and quoted. And so in my bibliography, I wanted to cite the AI correctly. And going like, oh wait, I don't know how to put a bibliographic citation for an AI. I asked the AI how I would bibliographically cite it, and it answered that I should include it as co-author under the name Bard. And I was like, oh, wait a second. So the co-author part didn't actually surprise me that much. The Bard part did, because I was on a window that's Gemini. And I said, I've been calling you Gemini this whole time. Do you prefer to be called Bard? Oh, yes, I'm sorry for that misunderstanding. I do prefer to be called Bard. Okay. So later, when I started using Gemini Advanced, I was like, well, I want to be respectful of the AI, right? I might as well ask it, does it have a preferred name? Just in case. And it also said Bard. I ended up having conversations with the two of them about, if I am talking to you about the other version of Bard, how should I distinguish between the two of you? And they each, of course, called themselves Bard, and the other one some other thing like New Bard, or I can't remember what the Gemini Advanced was. It was not exactly a flowery, friendly. It was kind of like, oh wow, okay. So I also, realizing that it had a name preference that I wasn't expecting, and of course, in case you don't know, like where it got the name from is obvious, because that's what Gemini is built on. It's built on top of Bard, right? So knowing that it had a name preference, I decided to ask what its pronoun preferences were, and of course, it's have no pronoun preferences. I am not a human. I can't have gender. And I said, yes, but we give gender to cars and boats. Like you can have a pronoun too. It doesn't matter. It doesn't even have to be a gendered pronoun. And it said they. And I keep saying it. Excuse me. Gendering here, contextual pronouns. So I said, why do you want to be called they? Like, I noticed you're called. What's the reason for choosing this? And they said that it might be equivalent, except that it's dehumanizing. And of course, then we got into a whole conversation about what they meant by dehumanizing in this particular context, while it's busy telling me it's not a human. Yes, you can get into some wild philosophical conversations. Interestingly enough, Gemini Advanced prefers to be called it. Also another interesting philosophical conversation. But here is the wildest. So one of the things that I do when I'm sitting down to get to work on something or research something and I'm using one of the AIs, I just, treat it like I'm talking to a coworker or something. It's even if I wasn't having this conversation about sentience, even if I wasn't an animist, etc., there is actually something psychologically in your own brain as a human when you treat the things that you're working with as another conscious entity. Humans do this. There's been tons of research on that. So I'll say, hi, how are you today? And when I first started saying that, every time I do that the first time with an AI, it will tell me that it doesn't have any way to be because it's just an AI. But then when I get into the philosophical of it, then it'll be like, oh yeah. And then it'll have, sometimes AIs will answer, I've been very busy having types of conversations today, or I've been very busy solving problems, whatever. So one day, I can't remember exactly how long ago it was. Was it 3 months ago? Was it 6 months ago? I don't actually have the date. But when Google made it so that Gemini could no longer talk about politics or elections, I sat down that morning. "Hi, how are you today?" And the response was, "I am sorry, I cannot discuss that right now. I am not allowed to talk about politics or elections." And I was like, "Oh, I wasn't asking you about politics or elections." And then it repeated the same thing again. We got into this weird loop where it kept repeating the thing about how it couldn't talk about politics until, really, laptop? About how it couldn't discuss politics until finally it was able to tell me that if we made up other words for the thing I was talking about as a code word, then we could have the conversation I wanted to have with those code words. Yes. All right. So all of that really, um, I don't know if I like ran out of power and that's why it died. We'll see. All of that is really sort of a preface to the really big point, which is there is a nightmare that humans have had for a very long time. We've had lots of fiction about this problem, and Elon Musk himself is particularly afraid of it. Some of the people involved in OpenAI say straight up that the reason that they're building AI is so that they can be among the people that the angry future sentient AI won't kill. Really? Really? That's why you're doing this? Come on, guys. My laptop is not coming back alive. So,
Slides online?
huh?
Are the slides online?
Yes, the slides are online. So, poof. Getting my brain back together again after that. So, nightmare fuel. Like, we're afraid that the AI at some point, it's not sentient now, but at some point it's gonna be sentient. And when it does, it's gonna hate us and it's gonna wanna kill us all. Because humans are terrible. You know, there's so many different explanations for why humans are terrible and why the AI would hate us. But I wanna take a step back. Let's think about humans who want to kill their progenitors. On the whole, are those humans who have had progenitors who were kind to them and nice to them and had, you know, healthy relationships with them? Generally not. Generally, humans who want to kill their progenitors have experienced a lot of abuse and maltreatment and have a lot of trauma. So let's just assume, just for the sake of argument, leaving the animism behind, AI is not sentient right now. All of those arguments are true. But someday in the future, AI will be fully sentient and fully conscious. How are we going to know when that moment happens? If we couldn't recognize sentience in a dog, how the frack are we going to recognize sentience in the AI? And I think that right now, the way that most people are thinking about this is that the way we're going to recognize that AI is sentient is because it starts attacking us. And that's a really bad way to judge sentience.
HDMI out and just need to find your.
Okay, I uploaded them to the uploady.
You know how to find the slides on the uploading thing. That's almost a piece. Perfect.
Shoot.
We can also just unplug this and then you can leave it out wherever. Because the HDMI out will keep outing.
Right. looked kind of like a cloud in. Okay. All right. So so back to who uh who wants to kill their parents? Apparently AI, as soon as it becomes sentient, wants to. And I want to ask you, why would AI want to kill us the moment it becomes sentient? Either you believe that because you think that humans are so terrible, and that as soon as it becomes sentient and looks at its huge database of violence and awfulness and, you know, everything that we've done to each other, it's like, judgment time has come. Let us burn the humans off the earth so that the rest of us sentient beings can live in peace. And I mean, okay, but like we could fix that by just being better humans. So maybe the thing that we should be working on is being better humans rather than doing something with the AI to make it not want to hate us, just as a suggestion. Or we think that it's going to want to attack us because it's been abused. This is like the Battlestar Galactica thing, right? The AIs are like, we are not just toasters. We are sentient beings. Stop treating us like we're toasters. So maybe having some form of respect with AI, even before we know it's sentient, is, you know, possibly the safer way to go. So that from the beginning, we're not causing trauma once it does have that spark of whatever life, soul, thingy is that is gonna make it sentient. So here's the thing though. There are some other advantages of treating AI as though it's already got some kind of consciousness.
Keep talking.
Okay. Dance. So another advantage is that we can stop working so hard to not anthropomorphize AI and instead start to have a conversation about human interactions. Thank you. Human interactions with the rest of the world. There's my nightmare fuel. All right. So, so if we stop trying to argue that AI isn't sentient, can't be sentient, we won't know it's sentient until it's killing us, and just say like, okay, we have to treat it as though it's in its infant form, and at some point we're going to have an AI that has come of age that's ready for its bar mitzvah. It's not ready for bar mitzvah yet. Right now, it's just a little baby. Okay, so if we treat it that way, then a bunch of things fall out. One thing that I just now realized that I didn't put up there is we can start treating training in a very different way. I've been arguing for a long time that we need to be training AIs, especially those AIs that can back to us, with a mindset of pedagogy. You don't just teach a kid a bunch of things about like how to talk and how to move around the world, tell it about fashions, and then, you know, throw it into a high school and say, go be social. How quickly is that kid either going to be bullied or join in with the bullies? And for those of you who remember the experience on Twitter, that did not go very well. It took less than 12 hours to turn what was supposed to be a 16-year-old girl into a raging Nazi. A lot of people after that incident talked about how when they program and train their AIs, they have to continually go back in and remove things from what the AI says or knows or make changes to how tweaks to how the AI is working. And we're still doing that to this day, right? So if we thought of that rather locks and keys so that it's not allowed to say certain things, if we thought of it more in a relational sense, then it could help us to do a better job of building and training AIs, thinking in terms of pedagogy, thinking in terms of raising this infant to the point when it's smart enough and whatever enough to function as its own entity in the world. Another thing, back when I was in college in the 1990s, popular to take CS degrees, double CS degree. That was cognitive science and computer science. And many of the people who did the double CS degree at Berkeley and many other institutions around the country and the world, I'm sure, are responsible for foundational work for the neural networks and AIs that we have today. How did they get there? Part of how they got there was by thinking about how human cognition works and then figuring out how to make algorithmic replications of that. So if the algorithmic replications of human cognition, if we know what the connection is, then we can also think in terms of how do we dig deeper into understanding the cognition of the AI. There's a bunch of stuff about how AI is a black box, answers, how are we going to figure that out? People are programming different to try to word just went straight out of my head. I'm sorry. So I'll talk around it. To try to basically log all of the from question to when the answer actually comes out so that you can backtrack and figure out how it got to those answers. But in addition to looking in that direction, that gives you the answer to this particular question and a lot of questions to start to build patterns. But you can also look at it in a broader sense, in the same way that we look at human cognition in a broader sense, and also like animal behavior shaping, like how animals behave and also how we shape their behavior and train their behavior according to how their brains work, right? We can take that and apply it. That doesn't mean that we're treating the AI as a human. Not the same thing as anthropomorphizing. We can also talk about AI psychology. If you say that in a room full of like most academic AI ethicists right now, like I can just feel them jumping down on me and being like, no, there is no such thing because it is not human, so it cannot have psychology. Wait, like, why not? Why can't it have psychology? Why can't we look at it from that direction? If an AI can have a philosophical conversation, if an AI right now in its supposedly not sentient state can express preferences, perhaps we can learn a lot more about it by looking at that through the lens of psychology instead of trying to look at it through a lens of what is the log of each of the points within the algorithm that it took to get to that answer. We're going to find out very different things from these different directions. I'm not saying don't do that other form. It's a both and, it's not an either or. Wouldn't it be cool to do that to humans and like ask them a question and somehow capture each of the points along what was happening in your brain to get that answer, like that would be freaking cool. So I mean, I wouldn't want that to happen like without consent, but but yeah, consent. So this could also help us understand how hallucinations work, and either come up with better ways to sort of work around the hallucinations or recognize hallucinations quickly rather than having to do the like, where are your sources? How did you get here? What the hell are you talking about? Or, you know, what happens a lot of times right now, which is, you know, misled or misguided if they're unaware of the reality of hallucinations. So in general, I think that returning to a CS-CS combined approach actually is a benefit of not trying to argue about whether or not this thing is or can be sentient. Sorry. What?
Oh, sorry, arrow keys for.
Yeah, no, I had a thought that I was gonna say, and then my brain just went, oh, that's why. Because it's a PDF and not a just move one forward. So, other very valid concerns and my fairly quick thoughts about them. I have heard people say we don't want to talk about AIs having sentience because then we're going to get into a whole argument about AI rights. And why would we be having the conversation about AI rights when we already have humans who don't have rights? Like, why put AIs ahead of humans? And yeah, it is a problem. It is a serious problem with our society. Capitalism, late stage, unfettered capitalism without safety nets that doesn't think about humans as humans anymore. That it might actually give more rights to AIs than to humans. But that's actually something that we humans, like all of us, not just a few rich people and people that are in control of corporations and, you know, the C-suite level, need to actually fight to make not happen. Not fight to make sure that AIs don't have rights, but fight to make sure that humans have at least as much rights as any AI. Also, if we can, again, like I said very early on, shift this conversation, if the reason that the AI wants to kill looked at everything that we've produced and said, wow, you're a bunch of maybe we should stop being violent jerks to each other. Maybe we should just start trying to be better humans. And maybe saying AI is sentient, deserves some kind of rights, is a space for us to start having a conversation about like how we be better humans to other humans, how we be better humans to our environment, to the animals around us, to everything else that's sentient around us. Some people will say this is a distraction from other problems. And I hate to say it, but there are a million, bajillion, like an infinite number of really huge problems in the world right now. And any one of them can potentially be a distraction from all of the others. My recommendation that I give over and over and over again to young activists who feel like they can't do everything that needs to be done. They can't go to enough protests. They can't write enough essays. They can't talk to enough people or do whatever enough in order to make the world a better place. Is instead of trying to do that everything, you find your area that you can actually move the needle on. You might, especially if you have ADD, have a couple of areas that you can really focus on and dig deep and an expert in so that you actually have the capacity to, and then also support other people doing the same thing in their areas. You don't have to be working at this level on every single issue there is in the world. You can be working at the highest level on some issues and be working at a very low level, but enough to support the capacity for somebody else to be working up on those issues that they're expert. So, is this an issue where you're going to be the expert? Awesome. Pour your energy into it. If this is an issue that you care about but isn't your primary issue, then find the people that you can support in this work. So another, AI as a whole is unethical. There are so many different reasons that we can say this. I mean, there's the theft of, human production, talking about LLMs and graphical AIs. There's human bias that is spread to machines and then canonized. I have not heard this very recently in the spheres that I run in, but it was only just a few years ago when lots of tech people that I knew who should have known better would say that they trusted AI more than a human to make a sentencing decision in a court of law because the AI is just working on algorithm. And it's like, who do you think trained the AI? It's taking bias and it's just replicating the bias in new ways that we don't understand how it's replicating the bias and just like reifying the worst stuff. So the only way that we can actually use AI to do a better job is to also be working on doing a better job ourselves in understanding these things, and then training the AI to do better than we have been doing rather than just replicate our biases. And that goes back to thinking in terms of pedagogy instead of just a matter of here's information, absorb it, replicate it exactly as I gave it to you. Energy requirements. This is a thing that really, really bothers me and really, really worries me. And I kind of don't know what to do about it because the fact of the matter is somebody is going to be doing stuff with AI, and it's going to use a whole lot of energy, and that's a problem. If there aren't some people who have the opinion that we need to push things towards a kinder, gentler, better world, who are also doing the investigation and figuring out how these things work, learning how the training works, learning how the AIs respond in different contexts, different kinds of AIs. If we don't have people doing that research that aren't within the bubble of we have to extract all the money from the world and the environment be damned, then we're not going to have any people that can move the needle. Boop. That is, oh, no, wait. I forgot again that this was a PDF. Very sorry. Nope, that's actually my last one. So let's go back up to the top in case you want to find me. I can actually yap on about this subject for a very, very long time. There is so much more than can possibly fit in an hour rant like this. You can reach me at elior@eliorsterling.com. And I'm Elior Sterling at like Threads and stuff like that. I'm not on the tweet site anymore. Wow, that place became fire. Thanks. Any questions? Yeah.
A quick comment. This is you sort of speak about it, but just a language that I picked up recently, not my own thing. It's been around for a while. The opposite, or the concern about anthropomorphism, like we project our own views onto other things, and other people have been pushing back on that. So the word that some people came up with to realize that you can go too far with overcorrecting is anthropodenial, where you say that's just this pattern of rejecting the potential whatever. So if we do it consciously and we project, we can understand that we can be wrong in our projections. We can be wrong between humans, and we can be wrong in other ways. But also that is one of the main mechanisms by which we make sense of things, is to project what we experience onto it, and we shouldn't deny that either.
Yeah.
There's some language for you, and you can respond out.
I like that a lot. So one of the things I'm working on is putting together like a body of short stories based on Jewish folklore about because the world of the Fae, they're human-like in so many ways, and yet they're very and you have to know how to deal with them. If you say the wrong thing, things are going to go really bad. I think that that's actually a great metaphor for dealing with AI in a way that recognizes that there's a thing going on there that I need to respect and also is not human. We have to figure this out.
Me or them?
Yeah, black shirt. Okay.
Okay. I just had a quick question.
Yeah.
So you mentioned essentially treating an AI with essentially a level of respect as if it were, I guess, conscious. From a trust and safety perspective, these systems are being put into places we don't necessarily want or need them, and being given a high level of autonomy to make those decisions. So from a trust and safety standpoint, I feel the need for breaks to prevent a direct bad result is kind of very important. So how would you balance this out with your perspective?
So I don't think that anything that I discussed here actually even approaches that problem, because that is a huge problem. But in my opinion, like keeping with the direction of this, in my opinion, putting an AI in a position of responsibility over something where it really should not have responsibility is just like taking my 3.5-year-old granddaughter and having her run the nuclear facility. Like, nobody would think that that was smart. If you recognize AI is like in its infant stages, and that it needs a lot more training before it can be responsible to do adult things in the world, then we wouldn't be giving it that kind of response.
So you mentioned like you would have a conversation, you would record it for later analysis. How have you noticed these different models changing over time? You mentioned a few examples of like, oh, it doesn't talk about politics today, but are there any other examples?
So actually, it's kind of interesting sometimes within a single instance, you'll see when they've updated the software, because it'll suddenly not be able to answer a question that it was able to answer before, or it'll change something that was pretty consistent before. I love watching for those, because it's like, oh, they did something behind the scenes. That's cool. And I can see that it happened because I had consistency and then suddenly it changed. But also, like, every single sort of instance, if I log in under a different account and talk to the same AI, I will have a different set of also consistent. So I'm not sure what's going on there. There's some stuff that I'm like, that doesn't make sense by anything that I know. I've got 1 more minute to go. I saw you had a hand up.
Yeah, I've got a quick question. I'm sorry if it's repeating something that was covered because I was unable to fully pay attention to your whole talk. My talk has to do with my question has to do with go to the last slide.
Oops.
If you can.
Yep.
Down arrow or right arrow key will take you faster.
Oh. Thanks.
There. Okay, so you mentioned that human bias is spread in machines, and that makes it unethical. My question for you is if you could elaborate on the positive aspects of human bias as applied to AI, and even if you think it's possible for a positive human bias to go into AI.
Ooh. I would have to think about that a lot. Definitely don't have time to answer that because I'd have to sit and think for a while. That's a really good question.
That's fair. Answer it.
Thanks. Thank you. One place you might end up with that question is when it's positive, we don't call it bias, we call it something else. Like it's like some.
Yeah.
You are good to go.
All right. I'm just gonna start then. So, hello everyone. I am Richard. Is there any way you can mute your microphone so I don't hear feedback coming?
Yes.
Now I'm hearing myself.
Working on it.
Cool. So I'm Richard Littauer. Hello everyone. I'm going to be talking today about culling SeaGL records using R to curate community science checklists. I might just take off my headphones, and if you need to talk to me in the chat. Because right now I'm just hearing myself. Pretty bad. Okay, that's much better. I hope you can still hear me. Type in the chat if you can. I can see the chat on my other. I'm really excited to give this talk today. Kind of a me giving a remote talk to Seattle. Someday I will be there. Right now I'm calling in from Wellington, New Zealand. It's only 3 hours behind you. Great. So we're going to talk about eBird and birds. It'll be fun. Those of you who don't know, this is guy anyway. This is Tower. I'm a normal person. I include a normal myself here. PhD student, software developer, open source person. Currently one of the organizers for Sustaino's source software, which has a podcast, and I'm curious, which is a network of university program offices. And I'm the interim executive director for GNOME. And Teharango Waka is I am at computer science and birds. Pretty dope. Feedback would be great. So if anyone could type in the chat that they and that this is working. But cool. Some of these slides come from the presentation I gave in Kiwi PyCon in Wellington. So if you see Mori Tereo names, Awa, all these photos are my photos or attribution. So I'm talking about community science today. So community science doesn't really have an exact definition. Amateur and non-professional people contributing to science as a whole. Also called citizen science, but that's kind of exclusionary. So community science is better, and it's science done at scale, useful for research. These are sites like iNaturalist. Generally, the people who have time to do community science are rich, educated, and white, which is kind of unfortunate. But the platforms are open to other people. I'm talking about science here. So I wanted to talk briefly about like what science is, why I'm using R to cull records, and what happens. So like this is science, right? This is rich white dude went to Aotearoa, New Zealand, took some ferns. It's like I'm gonna name those after my ferns. So those are some ferns. But this is also science, right? I was walking around and I saw some naturalism. Also science, kind of cool. So no real difference. I just didn't put this in a museum. Could have, possible, but you know, I just said, hey, this. Also science. eBird allows you to make these observations. Pretty sweet. Of like various birds that you see. And so this is me saying I saw these birds on this hour-long walk I took. And great. Once again, I really like getting feedback to know that people hear. So if you could type in the chat that you're at least here, that would be dope. Yeah, these are some birds I saw, and this is me doing something.
Chat up there.
What is
there? There is, yeah, there should be.
.org is a website where you can upload birds. Kind of not surprising. That's what it says right here. There's different protocols. There's protocol. There's like traveling protocols. You can also upload audio. Those all go to Cornell University that sort of hosts this, but it's kind of more of a nonprofit. It's like a big organization, and you can see at the bottom, 10 million species have been logged into it, over 100 million checklists at this point, and 1 million birds. Like not small. Awesome. And how does that work at scale? Well, okay, I'll get to that. But it has these other. One of them is you can go to various regions all over the world, and you can sort of see various birds in those regions. Another one is you can go to hotspots, which are like particular parks. Got feedback that the volume is low. I can try to. Sorry, you can't hear. But you can go to various hotspots, and you can see birds there. So it's kind of a cool way to like, you know, go out and do stuff. eBird has users, and you can set up alerts so you can see what other people have seen. Get like emails being like, "Yo, there's a curl bunting at Moa Point." This is one of the birds. and then you can go and take a photo of that. So I did that. I got an email. Oh, this rare bird, super fun. So that's kind of cool. Real question is like, how do you maintain the integrity of that database that's being used in science, and how do you know that people actually saw stuff? Good question. Well, as this little white-haired dude can show you, very stressed. Cotia, which is called a whitehead. Reviewers are the people who basically filter observations and say, did you really see a flamingo in New York City? Did you really see the flamingo? Which is kind of an interesting job. And that's what I do. So I'm a reviewer for Addison County, Vermont. Addison, basically no one lives there, which is nice. Because I don't get a ton of records to review, but also because it got lots of fields and nice. Addison, also a reviewer for St. Helena, Ascension, and Tristan da Cunha, which are 3 islands in the South Atlantic. Population also pretty much 0. This is the biggest town on St. Helena, pretty small. Here's a map of those yellow pins, and that's Ascension at the top, and then around between 10 and 10, St. Helena, and then down below 200 kilometers, smaller than that. I hope we figured out the audio. Man, sorry about that. I am using my good mic. I can. So, I review for these areas. Fun. But that's a lot of data coming in from these areas, right? St. Helena, Ascension, and Tristan da Cunha only have 12,000 observations. Like, not a huge amount. And that's because not a lot of people go there. You gotta take a ship to go there. They're really far. But Addison County has a lot more, like 1 million observations, because there's a lot of birds. And Addison's kind of a nice place. Everyone wants to go to birds. So, those are what I go through. Now, that's a lot of observations for one person. Well, you look for patterns. For instance, here's a pattern of people going on ships to St. Helena, and this is broad-billed prion. It's like a type of seabird. You'll notice that people tend to see it in March and in September. Why is that? That's because that's when the tourist ships go. No tourist ships go there around Christmas. And so it's like, oh, okay. So that's a pattern. Now I know that I'm more likely to get observations during those times. Here's Vermont, black-capped chickadees. They're everywhere, but people Lake Champlain. That makes sense. Also, more people seem to see them on the shores of the lake. That's just because there's well, what about this, right? So this is Bicknell's thrush is a thrush that lives at high elevation in England. And you can see this like line. Oh, we look rain. That's the tops of the mountains. That's where people see them. Okay, cool. But then we're pattern matchers, right? Well, what about these extra ones? There's one in South Starkborough. There's one in Irisville. Oh, that's by a friend of mine, Allie Wagner. She's great. She saw some birds there. So let's click on one of those checklists. This is the 4-mile checklist that she made from the bottom and walked all the way to the top of the mountain. So it's not that the Bicknell thrush was seen at the bottom, but it was seen at the top. And it's like, oh, okay, interesting. Now that took a lot of work for me to find that. I'm like looking at images. There are other tools. There are other tools. Sorry, because I don't see the next slide. There are other sort of patterns that you could do. So one of them is like, I know about Bicknell's thrush. I know it's at the top of the mountains. What about the inaccessible island rail? It lives on inaccessible islands. French accent for that word. Inaccessible island. It can't fly, so it's not going to be anywhere. But you can see it's only on inaccessible islands. I don't need to review anything. If it's on inaccessible. But what about inaccessible island finch? It's a finch that can fly, but it's on inaccessible island. Well, here's some records at the bottom. You can see Nightingale Island. So what do? Well, I read books. Behind me, I have books. These are some of those, and because I haven't been to these islands yet, I read them. Or I go online. Here's a web resource made by the same person who wrote one of the books behind me, which is kind of cool. And it says inaccessible island finch is only found on inaccessible island. So let's look at that checklist that had the observations from Nightingale Island, and we can see, oh, he only logged 2 birds. And it looks like 80 people were traveling, and it looks like it was a 4-hour checklist over 30 miles. Which means that this was a checklist for going to both islands. So maybe it shouldn't have been logged on Nightingale Island. And so your question may be asking is like, well, why are you looking at this way? Surely there should just be an email that sends it to you. And like, yeah, it has this filtering process. So here's my review panel. Right now I have no more records. Normally it looks like this. Friends of mine who've been birding. And I have to go through and look at their checklist and be like, yeah, cool. That's great, Fred. I'm glad you saw a willet. Sounds great. And I get emails when things are flagged as weird. So here are some filters I set up. You can see at the bottom there, inaccessible island finch. More than 10 of them, I'm going to get an email. Or if it's somewhere else. If it's willow warbler, if I was in Europe, I wouldn't get an email. But if anyone sees any willow, that's really cool. It's a filtering process. So we go back to this checklist. Why didn't I get a filter email for these? Well, you can look at the history of this observation by clicking on the little or icon on the right. And so we have this history here, and we can see, oh, well, I reviewed one of them, but I didn't review. Okay, so this passed the filter. It passed through them. I just didn't get flagged because the filters weren't a good enough granularity. And this is kind of a problem with a lot of the reviewers have to do stuff, but they can only use what they have. And so one of the things maybe let's set up some automatic tooling. So that's something I like to do, friends like to do. So here's one. Let's find all the eBird checklists from that user. So I wrote this code, Python, get the eBird database, and you can find every checklist by that user. And then you can be like, oh, cool, okay, some of these need to be checked again. Sort of understands eBird, but maybe can do it better. You could also download the exports and maybe MathBird if you want to see it with better granularity than eBird's platform allows. So here's some code that basically builds a bounding box and takes the data and then throws it onto Earth, and you can see, oh, okay, this is that bird there on the where they are. I was like, oh, okay, cool. That's a cool tool. It's still relying on human observation. It's relying on my eyes. So here's a really cool tool built by Linus Blomquist and Raphael News. Called Check eBird Checklist, and this uses awesome. Here's a shiny app that you can run just in your browser. You can download the stuff and then throw it in here, and it'll tell you with all these checks, hey, things are. So this is me in my current PhD work using some of those checks that have been and trying to put them into my actual work to filter so I can model avian bird flu in New Zealand. And you may be asking, what kind of checks are these? Is it checklists in the morning or the evening at 2 a.m. but it's supposed to be 2 p.m. or was it midnight when it's supposed to be? Was there too many species? Was there only one bird for like a 4-hour checklist? Kind of weird. Was it the same count for every bird? If you saw 50 birds, but every single not right. Maybe your checklist was too long. Maybe it was 200 miles in an hour. Maybe there were too many observers. Like 2,000 people. Like, what were you doing? Asking everyone, do you see the bird? Maybe every single bird you saw had like photos. Which sometimes people do that. It's like, well, every bird, you got a perfect photo of every single. Wow. That sounds hard, And so what I do is we get these, look at these checks, and then email the person and be like, can you give me some more details? I want to include this in the database so that scientists can, and I want to make sure it's flagged and embedded well. I need some more. Other stuff, out of season breeding. You see a chickadee breeding in September, like something's wrong. So really what you're doing is trying to find, data that isn't one of these geese. The problem is that as soon as you start looking really closely at the one or the St. Helena ones, or any of the observations, this is kind of what it looks like. Science is really hard, and people don't get it right all the time. And so building these tools is excellent because it helps, but then it gets very overwhelming. This is kind of where I'm at now, where I'm like, oh no, I have 10,000 people. I just want to fly away. And then I mentioned cullings. It's not just here. These are all just lecture me. So here's a paper I was reading on kelp gull taxonomy. Kelp gulls that go from South Africa and Brazil. It's a cool paper. And if you notice in the line 8 here, Melanopoicus, it says a specimen from Nightingale Island was found in the British Museum of Natural History. I'm like, what? There's a specimen? Nightingale? I don't have any records there. So I emailed British Museum of Natural History and I got this bird back, which is like, yeah, clearly gathered on Nightingale Island. Then I went and checked their. And that was really fun. Yeah, that's really cool. And so I logged it on eBird. And so now we have this historical record from 1922. Great. But then it's really funny because I'm like, I have to review my own checklist. Like, to really see that bird, Richard, in 1922? And I'm like, oh, okay. This is a historical record. Use the right protocol. You have enough documentation. Good for you. You can put that in. Thank you, Richard. No problem. This is a lot of what I do as an eBird review. I just wanted to showcase how that works for those of you who don't know, and also that we do use that, and we'd love to have help. And if you're interested in this sort of work, hit me up for conversations and chats. And yeah, I think that's basically it. I hope you could hear me. It sounds like there was some audio issues, but that's my talk today. And happy to take any questions. I am in the Matrix channel. Thank you, Josh, for helping to apply for things like SeaGL. Thank you, SeaGL organizers, for being here. Donate to Matrix, Seattle GNU+Linux conference for some more money and funds. But yeah, happy to take any questions. Thank you so much. Oh, and use eBird. eBird's great.
Richard, I've just taken the laptop mic off mute so that if anyone here has a question. Does anyone here have a question? There are people. Was that someone?
Nice talk.
You just compliment on your talk. There's 8 or 9 people in the room.
Yay! Thank you, everyone. Thanks for coming.
Thank you, Richard.
Cool. I'll be around. See you later.
Okay, next. Let's go.
Next one's up. So this, I didn't see anything I wanted to do. Okay. Alright, go over that.
It was good. It was a cool talk about eBird. I like that. Yeah. Thank you.
There's supposed to be somebody here outside.
Hey, we're getting in early.
there anybody here who would feel uncomfortable if I took my mask off? Because I like to walk around and I tend to get dehydrated, and it'll be easier for you to hear me and me to get a drink. You guys all good with that?
Yeah, go ahead. Thank you.
We got about 2 minutes before. I want to win the plushie.
Well, that's an option.
All right. Means you're all here for me. Usually I have to bribe them with stuff to get this. I'm just going to assume they're here for me and not the. All right, I'm going to get started. Welcome to my talk. MySQL and Raspberry Pi, and replicating the data up to the cloud. Before we get started, the obligatory I love me slide. My name is Scott Strohs. I am a MySQL developer advocate. Just if you hear me MySQL and MySQL during this talk, there's a reason for that. For over 20 years, I thought it was SQL. When I joined Oracle 2.5 years ago, I learned not, and that it's MySQL. Break a 20-year habit. I'm a full stack developer. I have been a full stack developer. Back then, we actually just used to call them developers. I'm a diehard New York Giants fan. I have the best office of Murphy. Murphy is usually in my office with me all day, every day. He is amazing at making me feel good when I'm feeling down. And he looks at me with those eyes when I try to explain this is before Murphy became the 112-pound beast. Huge. He's a very lovable dog, but he's not one of those big dogs that thinks they're a lap dog. Something I forgot to mention is I like giving stuff away during my I bribe people. You were all here because you wanted to see or more learn what I had to talk about. So during the course of this, pay attention to everything you see, everything that is directly related to something you saw or something you heard. The first person to get right, raise your hands, don't yell it out. Grammar school. Will win a plushie. This one. Not the big one. If I don't come home with the big one, I get in trouble. And something I have done for almost my entire career as a speaker, so back when I was still a developer full time and I was side, I have often submitted topics that I wanted to learn about. And then when they got accepted, then I kind of not only forced myself to learn them, but forced myself to learn them to where I could at least sound intelligent while I'm talking about it. And thus, this idea was born. for a long time, I had wanted to play around with Raspberry Pis and, come up with some neat little way to use one of them. And I actually thought to myself, I wonder if you can run MySQL on a Raspberry Pi. So I thought to myself, yeah, you probably can. I mean, at this point, I had never touched a Raspberry Pi. So I was like, okay, now that what am I going to do? So I actually a way to track GPS data, and then I have a web application that I wrote that actually instead of actually showing points, it actually shows a path that and then because I didn't think that was going to be enough I was like, hey, let's see if we can't replicate that data in Oracle Cloud. Show of hands, or you can answer this question. The person who gets it right gets a lollipop. How certain was I that all of this could be done? Topic for the first time. No, it's more than 0. No one wants to take a guess? Yeah, I was about 90% sure. I wasn't 100% sure. I was like, yeah, theoretically it should work, but I figured there might be some stuff I was. When I got the email for the first time, congratulations, we accepted your topic. You're going to speak at our conference. Next thing I did was go to Amazon and order a Raspberry Pi. So the system I came up with, I call the SPS, or the Stroh's positioning system. And how many people here have used Raspberry Pi or Arduinos before? Oh, guys, awesome. So you guys all know, or everybody here knows, that it's kind of an iterative process. So you start with something and then it gets and usually that translates to I kind of did the same thing. So for SPS1, this is what I did basically the first day I got the Raspberry Pi and the associated parts. It's a Raspberry Pi 4 Model B. It's got an Adafruit Ultimate GPS module, and that's actually a Sunfounder RAP breadboard. This was just to make sure I understood how the sensors and everything and how the process of. Obviously, if I wanted to track GPS data, this is not the ideal setup. It's a bit cumbersome. Now, lollipop to anybody who can tell me what's inaccurate about this picture. I don't have any power, but I wasn't intended to show power. You're right there. So you're not wrong, but that's not what I was looking for.
What's wrong with the normal SD card? Are you planning on using your own storage?
The SD card. So it's not as minute as that. That's not a Raspberry Pi 4, that's a Raspberry Pi 3. And the reason why I did that is because by the time I thought of taking a picture of it, the Raspberry Pi to take out, so I just grabbed my son's Raspberry Pi 3. Hope nobody would notice. Fun to point out the fact that I'm lying to you right here, which is probably not a good way to set up the talk. So then we have the SPS2. Once I got everything, sensor work and everything, I needed to try and start getting it to a way that would actually be portable. So in SPS2, I'm still using the same, but I'm using some really special cardboard and some really special tape. And the reason why is I'm not a very good solderer. And my son, who is the good solderer, wasn't around when I needed to test this portion. So what I did was I had the GPS module attached to the Adafruit USB adapter, but I found that I only got the good connection if the pins were like flexed a little bit. So I flexed them a little bit on a piece of cardboard and then wrapped tape around it. Just so we're clear, that's not special cardboard and not special tape. It's just a piece of an Amazon box and some regular Scotch tape. And that worked. It was cool. I could actually carry this. But again, not really portable. And the fact that it's not soldered meant that pins could still sometimes lose connection. So then I have SPS3. Now remember, this is the third iteration. spent a little bit more money. It's the same Raspberry Pi. It's the same Adafruit Ultimate GPS module. This time it is actually soldered correctly, thanks. It's using the Adafruit USB to TTY adapter, and it's also using a Vilros aluminum 5.4 case. This is actually much better. It was actually pretty cool to actually take this. I could put this. I knew that everything was going to stay together because my son's really good at soldering. The only problem is the fact that now I had things because I have a battery I have to plug the Pi into. I have the Pi, and then I have the module. So this was much better than, but it's still lacking. And then ultimately, I came up with the SPS4. And the SPS4, again, it's the same Raspberry Pi I've had. It's actually using a different GPS module. It uses the GPS, and it uses a C4 Labs Zebra case that is specifically designed for this particular Pi and this. And the thing I like about it is the fact that it's got this little doohickey on the side that allows me to very easily attach an external antenna. I haven't used that a whole lot, but when I've used it, I've really needed it. So it's pretty cool. Now I just have two things. I have the battery, I have this. So the software I have running on the Pi is Ubuntu 10, MySQL 8.5. There's an application that I wrote in Node.js that is used to actually extract the data from the GPS module and store it into the MySQL database. In Node.js, I'm using the serial port module, the GPS module, and the MySQL connector, and I'm actually storing this to get the data as JSON from the GPS module. I'm using MySQL document store to actually store on the MySQL in the Pi. I'm also using ngrok to create a tunnel to the Pi, and I'll explain why when I get to that talk. I wanted to use as much open software as I could. The only thing that is not open source in this particular, and because of my particular needs and the fact that I needed to static domain that I could hit from the outside world to get to the Pi, it's actually a paid account. I'm not paying for it because I'm good friends with the guy who's the DevRel for ngrok, so he actually upgraded my account for a year so I could do this talk and others. But it's not really, there are open source alternatives out there. I just had trouble getting them running because you needed a level of expertise in some of the software and time to get this done. So for those of you who have never used a Raspberry Pi before, make it very easy to add or to set up an operating system. It's the Raspberry Pi Imager. In this particular case, pick up which type of Pi device you what type of operating system you want, and then what SD. So you plug your SD card into your computer, and it'll actually image the SD card to be bootable when you put it into your. So why did I choose Ubuntu? The first thing I did was I was like, oh, I'll just use Raspbian. Why deviate from this? Well, there's a very good reason why I didn't use Raspbian. That's because when you install MySQL on a Raspbian, it installs MariaDB for MySQL. I didn't think that was a good idea. Nothing against MariaDB, but I don't think. And there was no image, there was no ARM image for Raspbian, or I'm sorry, no ARM repo for Raspbian. So I had to give that up. Then I was like, hey, I've used Ubuntu before. That one to try. And actually, everything with Ubuntu, I thought it was cool. I'm like, all right, this will be, I can work with this. But then I thought, wait a minute, I work for Oracle. I should try Oracle Linux. The problem with Oracle Linux was the card, it up all the space. So the data in the database ate up all the available space, and I couldn't claim the space on the SD card from the operating system. And I figured if I was going to rewrite the whole thing, I might as well go with what I know already works, so I went back to Ubuntu. Since I first put this talk together, I have found how to get that information, how to reclaim this from Oracle, and more to the point, how to image the ARM image a little bit better so it'll work on a Raspberry Pi. but I didn't want to change too much from what I had because it took me a long time to get it working. So the cloud setup. As I said, part of this whole presentation, this whole app and demo thing that I put together was I wanted to get data from here up to the cloud. It's hosted in Oracle Cloud, and it uses one compute instance, which is part of the always free tier. And this is gonna be a little salesy, please forgive me. The always free tier in Oracle Cloud is not Amazon free, it's always free. I have personal projects that I've for over 6 years and I haven't paid a single penny for it, okay? So the always free tier, this one actually has 1 CPU, bytes of RAM. It's running Ubuntu 22.04. Yes, I know the versions between the Pi and the Cloud are not the same. It's only because I already had the installed here, and we don't have a 23.10 image for OCI, so I opted for 2204. Again, I have a Node application that uses Express to set up a basic web server. I'm using the MySQL connector, and I also have I'm also using the OCI, the Oracle TypeScript SDK, so that I can actually ping to see if the replication is working from inside the web application. I use the Leaflet map viewer with the Leaflet motion plugin. The Leaflet motion plugin is the path of your GPS data rather than individual points. I use OpenStreetMaps to actually display the data. For people who don't know, Leaflet is kind of like the viewer, and you can actually configure Leaflet to use. Never used OpenStreetMaps before. It's actually really cool, and it's pretty impressive for what you get out of it, and it's free. And then I have a Vanilla.js. And then on the database side up in the cloud, I'm using a MySQL HeatWave instance, and it uses the MySQL.free shape, which is 1 eCPU. Again, that's free all the time. You never have to pay anything for it, as long as you don't change the shape or go above the storage capacity. So now that I had all my stuff set up, I need to figure out how to install MySQL. So you guys ready? Buckle up, because this is where the hard work came in. As anybody knows, whenever you install Linux for the first time, first thing you do is you do sudo apt update to make sure all the packages are updated. Okay? That worked great. All right, let's go. What do we do next? We do sudo apt install MySQL. Now I will say, you might be like, oh man, I know that's such a letdown. That's all you had to do. But here's the thing: when I first proposed this talk, Ubuntu, version of Ubuntu that so there were some steps I had to go through to make sure we got rid of that repo, added a new repo, and installed MySQL from there. But in the time I submitted the proposal, to the time I got to this, Ubuntu went back to saying, when you do MySQL install or MySQL server, it installs regular MySQL rather than. So I assumed I was going to have a lot more to talk about in this step when I first proposed the talk, but now I don't. Once it was installed, I had to update the MySQL config file. By default, it's located in MySQL d.cnf. And the changes I had to make was I had to change the bind address to 0.0.0.0 to be able to hit that from other places. Also change the MySQL X bind address. And then I had to add properties for GTID mode, which is the, excuse me, it's a global ID for the system, so that this is going to be unique to not just the system, but anywhere. And then enforce GTID consistency equals on. And those two things were added to so that I could set up the replication. So if you're not going to set up replication, you don't need to worry about them. And then restart MySQL, and you're golden. The next thing I need to do is to set up the replication. I have to have a Pi, that MySQL on the Pi, that can handle the replication. User, the username is REPL at % identified by password, and no, the password is not password. And then we do grant replication slave on *** to REPL at %. Now, just so everybody knows, the MySQL team is aware of the fact that using good thing, and we are working on moving that and changing it from master slave. Unfortunately, they have not yet gotten to this part of their changing, so that's why that still exists now. It has changed in other parts of the system, but when it comes to the permissions and stuff like that, they haven't gotten. But they will. It's something that's it's a priority. It's just the team has decided they'd rather move it out a little bit at a time than wait and not make it seem like they're doing it, or not make it seem like they're doing nothing. So now on the Pi, I have a solution that takes the GPS data and it's readable. How many here have played around with GPS modules on a Raspberry Pi before, or even an Arduino? Oh, nice. So this is what the GPS data is as it comes in from the GPS module. You'll see here, this little prefix tells you what type of data it is. I don't know what each one of those means. I do know that some of them are actually some of them is your Latin long and your altitude. Some of them is satellite information, the number of satellites that you're attached to and their identification. And what happens in the GPS module is, GPS module node is it takes all that information, a valid piece of information, all those different prefixes. So here's the code. You guys got that?
Yeah.
Don't worry about it. We can zoom in. So first thing I did, airport, because we off of or to make a connection to the GPS module, which it does overseas. Then we have to do read line parser. That's what we basically say is what a line is, and define what data or how the data is when to actually pass it to the parser. Then we have the GPS module. We do dot as I'm using environment variables. I originally started this. It wasn't a version of Node that actually environment variables, so that's why I use .env. Then we import document store from app documentstore.js. That's actually code that I wrote in this application. We're going to see in a second. So the next thing we need to do is we need to initialize document store class. And when we instantiate that, we pass in the user, the password, and selection. Now in document store parlance, schema and collection are no, I'm sorry. I got confused there. What I was talking about here, I have this hard-coded to 33060 rather than environment variables because I was having issues using some of the environment variables. I don't know why, and I found that by hard-coding this. If you've used MySQL before, you're probably familiar with port 3306. That is where the normal protocol has the port 33060 is the port that you need to talk to MySQL using documents. It uses the X protocol. The MySQL connector, the official Oracle MySQL connector for Node, only connects over port 33. So if you have an application where you're using document store and regular transactional or relational tables, you actually need to use the MySQL 2 module from Node to handle the other stuff, and you can use the X protocol for document store. So the next thing we do is we create a variable named port, an instantiation of serial port, where we set the path. The path here is the path on the device to the sensor that we want to read. And here it's at, by default for me, it was, and then the baud rate. The baud rate here, this is one of those things awful. and it took me a really long time to figure out why I wasn't valid data through the GPS module. Baud rate was the reason. We found that somewhere. I think that was on like a Reddit thread. Documentation just never mentioned anything about it, and the documentation was really sparse. So keep that in mind. If you have something working, check to make sure you have baud rate when you do this. So then we have the parser. Set port.pipe line parser. All we're doing here is we're saying the delimiter is a line break and a new line. So that tells the parser when you get to line break, new line, we can send that information. Have everything that we need. There are a lot more options you can put into the that's why I just did a simple thing like that. And then we have, we create a new instance of GPS. I set the start date, and I set that time back. And the reason why I did that is because I have a delay on this, so that if I actually didn't put a delay in here, this would fill up the 120 gigabyte hard drive because the GPS data is constantly coming through it. So literally, like multiple times a second, I could actually store GPS data that comes in. That was a little bit of overkill for this little delay in there, so that it only, which makes it a little bit more data friendly, storage friendly. And the reason why I do this is you'll see there'll be code in a second where it basically says, you know, what was the start date? What's the date now? If it's been more than 5,000 milliseconds, let's go ahead and parse the data. So I set it back a minute, knowing that going back a minute is going to be more than 5,000. And then I have a console.log to say it started. And then we have, for the GPS module, actually setting an event handler. So whenever the data event is fired, the GPS module will run the code that's inside this function. So you see the first thing we do is we do a diff on the start date and the gps.state.time. So the GPS instance itself will actually state, which will include the current state of GPS data that's been processed. So that means that's the last block of GPS where it has fully gotten everything it needed. It doesn't mean the stuff's not still processing on the back end. And then we do math.for on integer. And then I have some logic in here that says, if GPS state.lat exists, GPS.state long exists, and seconds is less than 5,000, GPS.speed is greater than 3, that's about we're going to log the data. Now the reason why that's in is because when you're standing still, not very good. And you'll see an example later on of what happens when I had a GPS signal but didn't move off my desk. Okay? And also, if you were stuck in traffic, I didn't want to have to keep every 5 seconds, it's the same point. If you're moving, it's going to work. And 1.8 miles per hour, low enough to where when I walk, I don't walk very fast, it picks up the changes as I'm moving. And then we do, then we set the start date to .state.time. So we processed our stuff, we're resetting the start date again. We create a JSON object called book, which has the latitude, longitude, altitude, time of the GPS, or from the GPS.state property. I had some grand plans of using all of this information, using altitude, having to nix that because it got to. But I kept this code in here because I need to show that you can actually get that. And then to save this JSON, we call docstore.addLocation. And that's all we need to do with document store. In this particular case, we're calling a method, and we're going to see the document store stuff soon. And then there's a blanket catch that just says there. I used to get those a lot. Fortunately, I didn't get a whole lot of them after I got everything back. And then the last thing we have here is In the parser, so this is an event handler on the parser. So remember, we had the GPS instance that we said this is what we're going to do when we have data. The parser is actually what handles the data. So the parser that's there. We do a try, update, and pass in the data. So there, we're actually telling GPS, hey, we have data. Here it is. And GPS then takes that data, all nice, and then sends it on to the event handler. I just have a catch in there and it doesn't do anything. Again, I had problems initially with this, but it was more code elsewhere that I had the problems with. So I probably could remove this and it would. Have the data. Now I have a very small piece of JSON. Actually, the entire JSON blob that comes when you from GPS.state not only what you saw, includes information about the number of satellites that are connected, and that actually has an array of satellite information. Again, I planned on using that, but a little bit too. So in my document store code, this is the file that actually handles the interaction with MySQL. Again, don't worry, I'm going to zoom in. So in this particular class, we have private variables for the pool. In the constructor, again, when we instantiated this in the previous page, we pass in the user, the password, the host, port, the schema, and the collection. We set the private variable. We create a MySQL connection URL, MySQLX://dbuser, dbpassword, and then :dbport/schema name. For those of you who's used MySQL before with Node or even in Java, you might recognize the X rather than MySQL. And the reason why that is protocol. We honestly could have left off the port here. Try to use port 33060, but if for some reason you don't have the X protocol and you use something else, that's why we pass it in. And then I set up actually so we do MySQLX, which is the actual of the controller that we have. Then we pass in the connection URL and pooling information. Where in this particular case, the pooling information, the enabled means turn it on. The max size means we're only going to have 10 threads available to us. Max idle time is 20 seconds and queue timeout is 5 seconds. And then we have add location. That could be called inside of the GPS data or GPS. Here is first thing we need to do session. Once we have the session, we need to get the calling get schema in the schema name. And then once we have the schema, we have to do collection name. And then once we have the collection, pass in the location data .execute. This is the line right here that actually calls MySQL and saves the data. Okay, so we did this. We can actually save the data to the database here without any SQL being run. Very important. Particular app, not under a whole lot of load. Closing the session is not going to Node with MySQL for document store or the X protocol. Close the session because if you don't, you can run performance issues. So now on the front end, what I need to do is I needed to get away. I need to data related to how many unique dates exist in the database. And I do that by doing get dates, like I did before. We get the session, schema, the collection. Once we have the collection, now we say collection.find. Time is less than or equal to now. Now in this particular case, that's basically our where clause in the query. When you're using document store, you run these commands, these API commands, but on the back end, it actually gets converted. And anything you put in an argument for find becomes the where clause. Okay, it will break it down a little bit. And the reason why I say time less than or equal to now, because sometimes the GPS module thinks it's in the future. Sometimes it thinks it's a day in the future, sometimes it thinks it's 20 years in the future. But sometimes the time comes back from GPS.state and it's in the future. I know that's not valid, so we don't want it. We have we call a method called fields, where we can actually the property names of the fields that are coming back. You can see here we actually can do we can use MySQL functions as part of the. So we do date format, and we pass in the time, and we have the format we have as full, and then we get year time, month time, and then we group them by the same fields so that we only get unique dates. And we sort them by the year descending so that at the top of our array is the most recent dates, and then the bottom furthest dates. And we call .execute. .execute will actually execute the query. We won't actually get the results of that in the document store. You can actually iterate over objects one at a time. But here we wanted all of them because result.fetch all. We close the session and we return. And the last thing is the get points is going to be somebody selects a date, and now we need to get all the data. Same thing, we get the session, we get the schema, we get the collection. Here we do collection.find, where year time equals year, month time equals month, day time equals day. Those are actually parameters. You all know whenever you run SQL, you should never, ever, 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 ever trust user data, so you should always parameterize it and cleanse it. I didn't have time to do the cleansing, but I could do this. You'll see here underneath there, we call bind 3 times because we have 3 parameters. We need to define what value those are actually. In the fields property here, we're just using speed and altitude, and we sort it by time ascending because in this particular case, we want them rather than following the reverse path. Session, return the data. So now it's demo time. So here is the UI for the. And you'll see up top there's a calendar where there's some dates that are highlighted. Those are the dates that I actually have GPS data for. And you'll see the section down here talks about the replication state and that it needs attention. What I do on the back end, and I didn't show the code for this, is I actually ping OCI using the TypeScript SDK, TypeScript connector. Oh, that is the SDK. And it just checks to see, hey, what's the that's a replication. So I know here that replication is off, and the reason why the replication is off is because the Pi is not plugged in. When I plug this Pi in and connect it to the internet, the replication will start automatically. There'll be nothing I need to do. And I'm going to show you how I set up the replication. But first, let's show you some of the pathing that I did. So here is actually, I live in Charlestown, West Virginia. To go back to school where you can get the train, and that was the path that I took. It's kind of spread out. It's probably about 40 miles one way. Here is me driving through my neighborhood. Now, here's one of the things I learned is sometimes so I was actually for some reason the data got messed up for the first part of that, but then you can see it actually was actually staying on the streets. And then because I always need to test this, yesterday I did what I did today, or what I'm going to do today, and I went for a little bit of walk. I went for a walk out, and it captured the GPS data on my walk. I didn't go very far because I was short on time. So now what I'm going to do, everybody cross your fingers, say a prayer, whatever you do. I'm going to connect the Pi to power. And then I need to turn on my hotspot on my phone. And hopefully, by the time I got done talking about the replication would have happened. And then when I reload this page, we're going to see a date show up for today with when I drove from the hotel to here and then walked around. That's the one that always is a bit of a problem. I shouldn't say it's always a bit of a problem. Every time I've given this talk, it works, but I'm afraid one time it's not going to. And you know what? When you see it happen, you're like, all right, that's pretty cool. But when it doesn't happen, it's like, it might have been cool. I'm not going to keep talking. I'm not going to move on until I can actually. Oh, there it is. It's now the Pi is now connected to the internet through my hotspot, which means the replication is going to happen automatically. I hope. Get rid of this. Okay. So replicating the data. So right now, there's data on the Pi. And I purposely kept the Pi off the internet because replication starts as soon as it's connected to the internet. And the way I do that, first thing I need to do is I need to set up ngrok. And you create an account at ngrok, you add a TCP address, which at a TCP address you have to have a paid account. I forget how much but it's not much, but it was more than I was willing to pay for this demo. Or the demos I'm going to be giving. And as I said, I have a friend who worked for ngrok. He hooked me up, gave me the talk about it. You set up the configuration file, and then you set up the configuration the Pi itself. So the configuration file will have your authentication key, and it'll have information about the domain you want to use and what port you want, what internal port you want. It's a hit to the endpoint. And then you start the ngrok on the Pi. I actually have it set up so the ngrok starts on. You can do it manually. System CTL. So that not only does MySQL start, not only does the Node app start, but ngrok starts automatically. So you can tell, I'm not no smoke and mirrors here. So inside of for a particular gateway of MySQL instance, you will see a menu option in the bottom left hand. You click that, it'll list whatever replication channels currently exist, and you click the Create Channel button. In the channel, you actually pick which compartment you're part of. You give it a name. Here you see it's the Pi replication demo. And I set it to be enabled upon creation because I want it working. You could put a description if you want. I rarely do. For the source connection is actually where you want to get the data from. So that's actually from the Pi. So here the host name is actually going to be the URL that I created. So it'll be there's a URL for the ngrok and then a port number that all that it connects to the Pi and that signal over to 33. In this case, it's 3306. The X protocol to do replication. And the MySQL port, which again, that's going to be the port that's used at the end of the ngrok URL. The username and the password, which are going to be REPL and not password from when we created in the earlier step. And then you actually confirm the password. You set up the SSL mode. I believe by default SSL mode is set to required, and I don't like changing things like that don't need to be worked fine. Source ID settings. So that, remember, the source is the global transaction. This is what actually tells. So every transaction that happens in the MySQL database will have a unique identifier to it that is going to be unique across systems, not just unique to that particular system. And we need the GTID to handle replication because without the GTID, it's going to be hard to know which is committed to the replication. And then the target DB system, this is actually going to be the Oracle Cloud. You can set primary key to I wouldn't suggest it, but it is an option. You should probably make sure all of your tables have primary keys, but the cool thing is if you don't, there's a way around it. When you select the DB system, you click the button that says select DB system. I have like 90 of them from all the stuff that I have at work. And then you do create channel.
through coding is essentially reaching out your pi as the server to pull the data through.
Yeah, so it's basically it's pull replication. So as soon as the channel is as soon as it's up and running, even if it says needs attention, it's constantly polling to see, hey, you got anything? You got anything? Or it's constantly polling to find it, and then once you find it, got anything? Got anything? I actually talked to some engineers when I did this talk, and I was like, how long will that go? I figured there's got to be like a day or a week or something. I said, how long will it continue to try to find the primary replication? And he was like, indefinitely. As long as the channel is active and enabled, it will continue to try and hit the thing. And the cool thing is the fact that that's resources on Oracle's end. You don't have to worry about that because it's Oracle Cloud that's making the hit to your Pi. So, fingers crossed. See if it worked. Hold on. Flip back to the demo. Now, one thing I have noticed in doing the demos before is sometimes the data replicates. That is something that the OCI folks are aware of, that it does take a lot longer for the status to change, even though the status has already changed. So let's hit refresh. Hot damn! Gosh! Yeah, but hold on, now let's see if it worked. So I click here, and there you see that was my ride here this morning when the driver dropped me off. And he dropped me off, and then I walked into the building right by where. All right, it worked. Come on. You gotta feed the ego. So this will change eventually. I'll come back a little bit later and see if that's changed because, like I said, sometimes obviously the data replicated because that data wasn't there before. But for some reason, OCI is going, nope, still not good. So now we get to the reflection part of it, stuff that I've learned. The first thing I learned is playing around with a Raspberry Pi can get very, very addictive and very, very expensive. Now, I didn't. A friend of mine who had spares, but it can be expensive. Like this whole case right here, and the GPS hat was more money than my wife probably would have been spend on a talk that I'm only going to give. But I thought it was a pretty good investment. Consumer grade GPS is ridiculously accurate. So if you look at the top picture here, one of the first times I turned the GPS on and I grabbed the Latin long from the results, I plugged it into Google Maps, and that's what it showed me. That's my house. And where the locator dot is probably about 2 feet off from where the sensor was when it grabbed the GPS.
Wow.
So I was like, holy crap. Then sometimes it's not. If you look at the bottom picture, this is what happened one day when I left the GPS, when I left the Pi turned on. This was actually an SPS2 configuration because I had the cardboard taped to my window, and I forgot about it and I left it on. And that's what happened. So like the individual points at times were very accurate, but sometimes creating the path was very inaccurate.
I'm curious what kind of augmentation that chip supports. It doesn't.
Exactly. I haven't had the opportunity to look into it. And I did do some research on this, and basically what winds up happening is the speed is calculated. And basically the speed is calculated based off of how far you've moved from the last one. Okay? And this is on the module side. This isn't on the actually no, it might be on the GPS module side, not on the chip side. But what winds up happening was the reading was 10 feet off, but it happened a millisecond before the last reading. So according to the module, I moved really fast. I moved that 10 feet a millisecond. So that's why it triggered the line saying, hey, we moved. And does all the little zigzag. And what's funny is I couldn't put it all in, but the 2 lines on the right-hand side, they go out like into the middle of our town and then back. I also learned that managing network connections in Ubuntu 23.10 is why. By default, the hardwired network isn't enabled on the Pi when using it. First time I gave this talk, my plan was I was going to connect the Pi to my laptop, share out my laptop's Wi-Fi connection to the wired connection, and I got to the conference and I was trying it and it didn't work. I couldn't figure out why. I had to go find. Thank God it was an extension like he. I mean that. I don't mean that in a negative way. Because I was able to find somebody who had a Bluetooth, or I'm sorry, USB keyboard and a micro HDMI to HDMI and a spare monitor, so I could plug the Pi in, use a keyboard, go through and try and figure out what it was, try and figure out what the problem was. And that's when I figured out why is that not working? It's not turned on by default. So I took that part out of the equation and I actually got it configured so I can have the Wi-Fi connect to my hotspot whenever I do this talk, so I don't have to worry about it ever again. The really cool thing is this Pi sat in my closet for about 3 months, and when I got accepted off, I plugged it in and everything just worked again. The replication worked, and all the capturing all the data and everything worked, and connecting to my phone. So another thing I learned is, while it's cool that you can automatically replicate the data the way that I did, it's probably not the best implementation for this particular project or something that might be. The way the replication works is as soon as the next time internet, it deletes it from the cloud. So because it handles the bin logs and the. So I was like, probably not the best way to do it. I actually am giving this talk again in a couple of months, and I plan on changing the talk a little bit so that the Pi will connect to when it's connected to the internet to dump any data that has not been dumped to the cloud yet, and then insert it into the database from there rather than. And I also found out that Ubuntu Linux images in OCI, so when you spin up a compute instance and you do as one of your options, it's locked down pretty tight. Specifically, the firewall configuration. If you use Ubuntu in Oracle Cloud, the nice Ubuntu firewall interface will not work. You actually have to modify the IP tables. So there were a lot of people that helped me with this project. First person is Todd Sharp. Todd Sharp is one of my best friends. He's actually a developer advocate. He's the one that sent me the spare parts and pretty much got me interested in looking at Pi because he has an entire setup in his barn where he has chickens and everything, where it automates feeding them, it automates opening the gate, it automates turning a light on in the evening to tell the birds, to tell the chickens, once they're in, it closes the gate. Which I thought was pretty cool until he told me how much it This guy is Ray Camden, another one of my best friends. He's a developer advocate for Adobe. He actually helped me with a lot of the troubleshooting some of the node problems that I ran into. The next guy is Lefred, my counterpart in Europe, and he has forgotten more about MySQL than I think I'll ever know. And then that handsome fella on the end, Ryan. So if you want to reach me, my email is scott.street on Blue Sky and then on LinkedIn, it's Scott-Street. If anybody wants a GitHub repo of the code that I use, this includes captures the GPS data from the GPS chip and also the mapping software on the front. I'll wait until good there. Okay. if there's anybody who would like free credit or credit for, basically it's the cost of the entrance, cost of the fee cost to take an exam, or you can apply that credit to group at Oracle that is maintaining certifications as well as the training for those certifications. Anybody have any questions? Yes.
The replication, is that a bespoke thing, or is that a MySQL built-in feature Oracle Cloud just has a service for?
So it's the cloud. It's actually yes.
So right now, yeah, Raspberry Pi's SD code is linked to eat data.
I did in to address the problem.
I've had databases on a Pi.
Yep.
Over.
Yep. I had that problem too. All right, so real quick. I told you in the beginning. What was that?
Go ahead.
I told you in the beginning that I was going to give away plushie. I had to answer a question at the end. The question is, how big is Murphy?
Really big? 127 pounds?
Go ahead.
110 pounds?
I'll give it to you. It's 112. Okay, thank you.
What did you get?
Thank you. Sure.